PacketFence is a major in network security. As a source network access control system, it empowers you to manage both wired and wireless networks effortlessly. Imagine having features like captive portal registration, which simplifies user onboarding, and device isolation that keeps potential threats at bay. Plus, with its abnormal activity detection, you can swiftly identify and respond to behavior. This means you have complete control over who accesses your network, ensuring that only authorized devices connect. Whether you're a small business or a large enterprise, PacketFence is designed to scale with your needs, network security not just effective, but accessible. PacketFence helps manage wired and wireless network security. It offers features like captive portal registration, device isolation, abnormal activity detection. With PacketFence, you can control accesses your network and ensure only authorized devices connect. It's ideal for business any size. Let's dive into how it works in the next. PacketFence is a powerhouse when it comes to network access control. Imagine having a system that not only supports captive portal registration, but also seamlessly integrates 802.1x authentication. This means that every device connecting to your network is verified and secured right from the start. VLAN isolation is another game changer, allowing you to segment your network and protect sensitive data. Plus, with integration into intrusion detection systems like Snort and Suricata, you're always a step ahead of potential threats. But it doesn't stop there. PacketFence takes proactive security to the next level with vulnerability scans using tools like Nessus or OpenVAS. It can even detect abnormal activities and automatically isolate compromised devices, ensuring work remains safe and sound. With these features, PacketFence empowers organizations to maintain robust network security effortlessly. PacketFence offers a rich feature set for network security management. It supports captive portal registration, 802.1x authentication, and VLAN isolation. It integrates with intrusion detection systems like Snort and Suricata. It also supports proactive vulnerability scans using Nessus or OpenVAS. PacketFence detects abnormal activities and automatically isolate compromised devices. Stay tuned as we explore each feature in more detail. When you connect to a public Wi-Fi network, you might notice a little detour before browsing. That's the captive portal in action. It's a web page that pops up, ensuring you register or log in before gaining full internet access. Think of it as a gatekeeper for networks in places like airports, hotels, and coffee shops. Here's how it works. You connect to the Wi-Fi, and instead of diving straight into your favorite website, your device gets redirected to the portal. This page usually asks for some basic info, like your email, room number if you're at a hotel, or even a username and password for universities. You might also need to accept some terms and conditions. Once you fill out the form and hit submit, the magic happens. The system grants you access, often by whitelisting your device's MAC address or giving you a temporary session. Captive portals can also collect data, enforce bandwidth limits, and even showcase custom branding. It's a smart way to manage network access while keeping users informed and secure. A captive portal registration is a web page that users are automatically redirected to when connecting to a public or private network, often Wi-Fi, before they are granted full internet access. It's commonly used in places like airports, hotels, coffee shops, universities, and corporate networks. How it works. User connects to the Wi-Fi. Before any browsing is allowed, the device is intercepted and redirected to the captive portal. The portal displays a registration or login form, often asking for email address, room number in hotels, username and password for universities or companies, acceptance of terms and conditions. Once the user submits the form, access is granted, typically by the system whitelisting the user's MAC address or assigning a session. Common features: user authentication, data like email numbers, terms of service acceptance, bandwidth time limits, custom branding. Do you want to set one up, or are you troubleshooting a portal issue? .802.1x authentication is a powerful network access control protocol that ensures only authorized devices can connect. The 802.1x flow. PacketFence offers two powerful enforcement methods, VLAN and inline. VLAN enforcement is like a traffic cop, moving devices between VLANs to ensure they follow security policies. It's efficient and helps maintain network segmentation. On the other hand, inline enforcement places PacketFence directly in the traffic path, allowing for real-time monitoring and control of devices. This method for immediate response to threats. But why choose one over the other? VLAN enforcement is scalable and less intrusive, while inline enforcement provides deeper insights and control. The best part, you can combine both methods for a hybrid approach, matching security and flexibility. Understanding these options is tailoring your network security strategy effectively. Choose wisely for a robust and secure network environment. PacketFence supports two enforcement methods, VLAN and inline. VLAN enforcement moves devices between VLANs to apply security policies. Inline enforcement places fence directly in the traffic path to monitor and control devices. A hybrid approach combining both methods is also possible. Each method provides different levels of scalability and security. Let's learn how to choose the right method for your network.
Before diving into PacketFence deployment, let's talk system requirements. First off, you'll need a solid database server. MySQL is a great choice. Pair that with a reliable web server like Apache. If you want enhanced functionality, consider adding DHCP, Radius, and IDS systems. Now, for hardware, aim for at least a 3 GHz CPU, 4 GB of RAM, and 100 GB of disk space. We'll keep things running smoothly.
As for operating systems, you're in luck. PacketFence supports RL, CentOS, Debian, and Ubuntu. Remember, a good grasp of Linux is crucial for a successful installation. So, the right tools and knowledge, and you'll be ready to roll with PacketFence in no time. Installing PacketFence, ensure your server meets system requirements. You need a server like MySQL, a web server like Apache, DHCP, Radius, and IDS systems.
Recommended hardware includes 3 GHz CPU, 4 GB RAM, and 100 disk space. Supported operating systems are GL, CentOS, Debian, and Ubuntu. Good Linux knowledge is essential for setup. But before diving into pack deployment, let's talk system requirements. First off, you'll need a solid database server. MySQL is a great choice.
Installing PacketFence is a straightforward process, but it requires a few key steps to ensure everything runs smoothly. For Red Hat-based systems, the first thing you need to do is enable the EPEL and RepoForge repositories. This is crucial for accessing the necessary packages. Once that's set up, you can use yum to install PacketFence along with its dependencies. On the flip side, if you're working with a Debian-based system, you'll want to add the PacketFence apt repository to your sources list. After that, a simple apt-get install command will get you up and running. Before diving into the installation, don't forget to update your system. This ensures you have the latest packages and security updates, which is always a good practice. With these steps in mind, you're well on your way to deploying PacketFence effectively. Let's get started. Before diving into the PacketFence installation, let's ensure your OS is primed for success. Start with a minimal installation. Less is more here. Next, disable firewall services, SE Linux, and AppArmor. These can interfere with PacketFence's operations. Now, don't forget to update your system with the latest patches. This keeps everything secure and running smoothly. If you're on a RHEL system, configure the EPEL repository. It's essential for accessing necessary packages. Prepare your server for DHCP, Radius, MySQL, and Apache services. These are the backbone of PacketFence. Remember, a correct OS setup is crucial for PacketFence to operate properly. Get these steps right, and you'll be on your way to a seamless installation experience. For a smooth PacketFence installation, perform minimal OS installation. Disable firewall services, Linux, and AppArmor. Update your system with the latest patches. Configure required repositories like EPEL for RHEL systems. Prepare your server for DHCP, Radius, MySQL, and Apache services. Correct OS setup is crucial for PacketFence to operate properly. PacketFence makes it easy to keep your software up to date with its dedicated package repositories. If you're on RHEL, the first step is to add the PacketFence repository under extra-yum.repos.d. Just create a new repo file and fill it with the repository details. It's straightforward and ensures you have access to the latest updates. For those using Debian or Ubuntu, you'll want to add the PacketFence repository to your apt sources list. This involves editing the sources.list file and adding the necessary lines. Once that's done, run an update to refresh your package manager's cache. Always double-check that your package manager can access these repositories before diving into the installation. This simple setup can save you a lot of headaches down the line, keeping your PacketFence installation smooth and efficient. Downloading and setting up PacketFence software repository access. PacketFence provides package repositories for easy access to software updates. On RHEL, you add the PacketFence repo under yum.repos.d. On Debian or Ubuntu, you add the PacketFence repository to your apt sources list. Always ensure your package manager can access these repositories before proceeding with installation. configured PacketFence. Accessing the web administrator interface is a breeze. To HTTP your 443. This is your command managing everything from users and to violations and V. The default username min paired with the password earlier. Here, you'll find a user-friendly layout that makes it easy to navigate through system settings to activity. Adding new devices or addressing security violations, this portal is where the magic happens. It's all about keeping your network secure and efficient, so dive in and take control of your PacketFence operations. Once configured, PacketFence's web administration interface is available at HTTPS. Your IP, MART143. Users, devices, violations, VLANs, and system settings. The default username is with the password you created earlier. This web portal is where you'll control most PacketFence operations. The file pf.conf is where the magic happens for PacketFence. Nest ISRR local pf.conf. It's the heart of global settings. Here, you can define essential roles like VLAN mode and configure captive portal IPs. It's like the command center for your network. You'll find default parameters in pf.conf defaults, which is a great starting point. While it's tempting to dive in and edit the file directly, I recommend using the web interface for most changes. It's user-friendly and helps you avoid those pesky manual errors. However, if you're feeling adventurous and need advanced customization, direct edits are definitely an option. Just remember, with great power comes great responsibility. The file pf.conf holds global PacketFence settings. Located in .usr local pf.conf. It defines roles like VLAN mode, captive portal IPs, and more. Default parameters are in pf.defaults. It's recommended to edit settings through the web interface to avoid errors, but direct file edits are possible with customization. The pf.conf file in PacketFence, located at .usr local pf.conf pf.conf, is essential for managing network access control. It holds the core configuration settings that dictate how PacketFence operates. Think of it as the brain of the system, influencing everything from authentication methods to logging and portal behavior. Inside this file, you'll find an INI-style format, where key value pairs are neatly organized under section headers. This structure makes it easy to configure integrations with external systems like Radius, LDAP, and DHCP. Each setting plays a crucial role in ensuring seamless network management and security. By tweaking these parameters, you can customize how PacketFence interacts with your network, enhancing both user experience and security protocols. Understanding and managing this file is key to unlocking the full potential of PacketFence. The pf.conf file in PacketFence, located at USR local pf.conf pf.conf, is the main configuration file that holds global settings for how PacketFence operates. It stores core configuration settings used across PacketFence services. These settings affect network access control, authentication methods, logging, portal behavior, and integration with external systems, Radius, LDAP, DHCP, etc. This file is typically in INI-style format, with key value pairs under section headers. Managing Apache for PacketFence's captive portal is all about print security. The dynamic duration lives in USR local pf httpd.conf.d, where files like httpd.admin, httpd.portal, and httpd.webservices each play a crucial role in handling specific services. SSL is enabled by default, which is fantastic for security. Remember, those self-signed certificates are just a temporary fix. Placing them with real certificates is essential for building true users. A well Apache setup not only ensures your captive portal runs, but also protects sensitive data. So, dive into those configuration files, make the necessary adjustments, and watch your captive portal thrive securely. PacketFence uses a dynamic Apache configuration stored in USR local pf conf httpd.conf.d. Files like httpd.admin, httpd.portal, and httpd.webservices manage specific services. SSL is by default. Self-signed certificates can be replaced with real ones. Correct Apache setup ensures the captive operates securely.
PacketFence is a powerful network access control system that leverages Apache as its web server to manage its captive portal. The configuration is modular and dynamic, stored in the directory /usr /local /pf /httpd /fd/. Here, you'll find essential files like httpd.admin, which demonstration interface, httpd.portal for the user-facing captive portal, and httpd.webservices, managing applications. SSL is enabled by default, using self-signed certificates that can trigger browser warnings. For a more secure experience, consider replacing these with valid certificates from trusted authorities like Let's Encrypt. Proper Apache configuration is crucial. It ensures a secure and stable captive portal, segregates services effectively, and enhances both network security and user experience.
These configurations can lead to broken portals or insecure logins, so attention to detail is key. Would you like to dive deeper into a sample httpd.portal file or guidance on SSL setup? Sure. Here's a breakdown of the script and explanation of the Apache configuration management for a PacketFence captive portal setup. PacketFence is a network access control (NAC) system, and it uses Apache as its web server to manage various components of its captive portal, like user authentication, administration, and web services. Apache's configuration in PacketFence is modular and dynamic, meaning it's built from different smaller config files. The key configuration path is usr local pf/conf httpd.conf.d, where PacketFence and Apache configuration files.
These files are dynamically used to configure the Apache server specifically for PacketFence components. Important files include httpd.admin, which handles the administration interface where admins log in to manage PacketFence, httpd.portal, which controls the captive portal, the page users see when they first connect and must log in or accept terms, and httpd web services, which manages API and background services communication. SSL sockets layer is enabled by default. Self-signed certificates are used, which are functional but just are warnings. Replace self-signed valid ones from Let's Encrypt or a commercial CA for a trusted experience. Property configuration matters because it ensures secure and separation of the captive portal, allocation of services, admin interface versus user portal, and is critical for network security and user experience. Misconfiguration can lead to broken portals, insecure logins, or access issues. Would you like a sample httpd.portal file or guidance on setting up an SSL certificate for PacketFence?
Running PacketFence on a Linux server? Let's talk about Linux. If you want everything to run smoothly, you need to disable Linux. That's right, set it to disabled. Open up your terminal and edit the etc. Linux start config file. Find the line that says Linux enforcing and change it to Linux disabled. Save those changes and reboot your server. Trust me, skipping this step can lead to major service failures. You'll be left scratching your head, wondering why things aren't working. So, take a moment to make this adjustment. Your PacketFence setup will thank you, and you'll avoid a world of headaches down the line. Simple, right? Now go ahead and get that server running like a well-oiled machine. Disabling Linux can be crucial for ensuring smooth PacketFence operation. First, assess your PacketFence server. Once you're in, it's a simple tweak, but it makes a world of difference. After you've made that change, save and exit the editor. Now it's time to reboot the system. Just type reboot and let the server do its thing. When it comes back up, Linux will be disabled, allowing PacketFence to operate without any hiccups. This is a straightforward step that can save you from a lot of weeks down the line. Remember, sometimes less security can mean more functionality, especially in a controlled environment. Managing user roles in PacketFence is essential for robust access control security. By configuring roles in the web GUI under Configuration, Users, Roles, you can tailor permissions for different users and devices. Imagine having distinct roles like employee, guest, or machine auth. Each role dictates crucial aspects such as VLAN assignments, access rights, and device limits. For instance, an employee might have full access to the network, while a guest could be restricted to a specific LAN with limited internet access. This granular control not only enhances security, but also optimizes network performance. By effectively managing these roles, you ensure that every user device has the appropriate level of access, keeping your network secure and efficient. Managing user roles in PacketFence is essential for robust access control security. When it comes to configuring authentication sources in PacketFence, you have a powerful toolkit at your disposal. Imagine seamlessly integrating Active Directory and LDAP for robust user management. You can also tap into your internal SQL database, in which your existing user data is leveraged effectively.
But it does stop there. With OAuth, you can offer users the convenience of logging in through platforms like Google or Facebook, making access smoother and more familiar. Plus, for those who prefer a more traditional approach, email and SMS-based logins are at your fingertips. What's fascinating is the way these sources are prioritized.
You can set rules to automatically assign roles based on the authentication method used, streamlining user access while maintaining security. This flexibility not only enhances user experience but also fortifies your network's integrity. With PacketFence, you're not just managing access, you're orchestrating a seamless authentication symphony. To add an LDAP authentication source in PacketFence, start by opening the PacketFence web admin base. Navigate to Configuration, then Users, and select Sources. Click on Add Source and choose LDAP. Now, it's time to enter the details. Input your LDAP server's IP address, the ban, and the necessary credentials. Make sure everything is accurate. This is crucial for a successful connection. Once you've filled in the information, save the source. Before you finalize, forget to test the connection. This step ensures that everything is configured correctly. Finally, link your new LDAPs to the captive portal profile. And just like that, you've integrated LDAP authentication into PacketFence. PacketFence needs to know your switches and access points to function effectively. To get started, you can add device information directly in the your local pf switches.conf file or through the web GUI. It's crucial to specify the device IP, SNMP version, VLANs, trunks, or uplinks. This detailed setup allows PacketFence to manage and control your network devices seamlessly. Think of it as giving PacketFence a roadmap to navigate your network. The more precise the information, the can enforce policies and enhance security. So, take a moment to ensure everything is correctly. Your network's health depends on it. PacketFence needs to know your switches and access. Add device in .usr local pf switches.conf or via web GUI. Device IP, SNMP version, VLANs, and uplinks. This ensures PacketFence can control and manage them properly. Using the SNMP protocol for switch communication in PacketFence is essential for seamless network management. With support for SNMPv1, SNMPv2C, and SNMPv3, you can tailor your setup to fit your security needs. Start by configuring your community strings and authentication users in the switches.conf file. This is where the magic happens. Correctly setting up SNMP allows for dynamic VLAN changes and real-time monitoring of port states on your managed switches. Imagine the efficiency of having your network adapt on the fly, all thanks to a solid SNMP configuration. Remember, a well-implemented SNMP setup is not just a technical requirement, it's a cornerstone for your production success. Get it right and watch your network thrive. Using the SNMP protocol for switch communication in PacketFence is essential for seamless management. With support for SNMPv1, SNMPv2C, and SNMPv3, you can tailor your setup to fit your security needs. I'm diving into adding a new Cisco switch to PacketFence for VLAN enforcement. First, I open the PacketFence admin web GUI. It's all about that seamless navigation, so I head over to Configuration, then Network, and Switches. Here's where the magic happens. I click on Add. Now, I enter the switch IP address, and for the type, I'm going with Cisco, Catalyst 2960. Next up, I input the SN community string, which is crucial for communication. Then I specify the VLANs I want to enforce. Once I've filled in all the details, I hit Save Changes. But we're not done yet. I need to restart the switch daemon to apply those changes. Finally, it's time for the real test. I to the switch and watch as it gets assigned to the correct VLAN.
Success! That's how you integrate a Cisco switch into PacketFence for effective VLAN enforcement. Simple, efficient, and roll. I'm diving straight into new Cisco switch to PacketFence for VLAN and first, I open the PacketFence admin web GUI. It's all about that seamless navigation, so I head over to Configuration, then Network, and find Switches.
When managing network devices, understanding CLI and web service communication is crucial. Besides SNMP, PacketFence offers robust CLI access through SSH and Telnet, allowing you to configure VLANs and ports directly. This hands-on approach gives you immediate control over your network settings. On the other hand, web services using HTTP and HTTPS enable seamless interaction with modern API-enabled switches. This means you can automate tasks and integrate with other systems effortlessly. Just remember, configuring these settings in switches.conf is essential for smooth operation. Mastering both CLI and web services not only enhances your network management but also empowers you to optimize performance and security across your infrastructure. When managing network devices, understanding CLI and web service communication is crucial. PacketFence simplifies network management by auto-generating DHCP and DNS configurations directly from the networks.conf file located at usr local pf-conf. Let's break down some key components. First, the network address defines the range of IPs within a specific subnet, while the gateway serves as the access point for devices to communicate outside that subnet. The net mask, on the other hand, determines which portion of the IP address identifies the network and which part identifies the host. When it comes to DHCP, defining IP ranges is crucial. This ensures devices receive IPs dynamically without conflicts. Lease times dictate how long an IP is assigned before it can be reused, striking a balance between availability and stability. Lastly, DNS server settings are vital for name resolution, allowing devices to find each other seamlessly. Proper network configuration is essential for effective device isolation, ensuring that each device operates securely within its designated space. This is how PacketFence keeps your network organized and efficient. Inline mode positions PacketFence as a gateway between clients and the network, capturing all traffic seamlessly. This means it can detect devices passively, which is a game changer, especially in environments where VLAN switching isn't an option. Imagine being able to isolate clients instantly. No delays, just immediate action. This capability is particularly beneficial in small or unmanaged switch environments, where traditional methods might fall short. With PacketFence in inline mode, you gain enhanced visibility and control over your network, ensuring security and efficiency without the complexity. It's a smart solution that simplifies network management while keeping your environment secure. Inline mode places PacketFence between the client and network, acting as a gateway. It captures all traffic, detects devices passively, and is useful when VLAN switching isn't available. It can isolate clients instantly and is ideal for small or unmanaged switch environments. Inline mode positions PacketFence as a gateway between clients and the network, capturing all traffic seamlessly. This means it can detect devices passively, which is a game changer, especially in environments where VLAN switching isn't an option. Imagine being able to isolate clients instantly. No delays, just immediate action. An isolated VLAN is a powerful tool in network security, especially in environments like data centers. Imagine a space where devices are grouped together but can't talk to each other. This is exactly what an isolated VLAN does. It allows devices to communicate only with a promiscuous port, like a router or firewall, ensuring that all traffic is monitored and controlled. In a multi-tenant data center, this means that virtual machines belonging to different customers are completely isolated, preventing any direct communication. This setup not only enhances security, but also simplifies compliance with strict regulations. Isolated VLANs are part of a broader private VLAN configuration, which includes a primary VLAN that ties everything together, and community VLANs that allow limited communication within designated groups. This layered approach to network segmentation is essential for maintaining a secure and efficient environment. An isolated VLAN is a special type of VLAN used primarily in private VLAN configurations to restrict communication between devices within the same VLAN. It's often used in environments where security or traffic isolation is critical, such as in hosting environments or data centers. Key characteristics of an isolated VLAN. Devices in an isolated VLAN can communicate only with a promiscuous port, like a router, gateway, or firewall. Devices in the same isolated VLAN cannot communicate with each other, even though they are in the same subnet. It's part of a larger private VLAN configuration, which typically includes primary VLAN, the main VLAN that ties everything together. Isolated VLAN, for ports that need total isolation from each other. Community VLAN, allows communication between members within the same community, but not with other communities or isolated ports. Use case. Example. In a multi-tenant data center, isolated VLANs can prevent virtual machines belonging to different customers, or even the same customer, from communicating directly, forcing all traffic to go through a firewall or router for inspection. When users connect to your network, the captive portal is their first impression. It's crucial to make it count. You can customize the login form to streamline user access, ensuring it's user-friendly and intuitive. The registration page can be tailored to capture essential information while keeping it simple. Don't forget the terms of service. Make them clear and concise to build trust. Branding images are vital too. They should reflect your organization's identity and create a cohesive experience. To make these changes, simply navigate to the admin portal, then configuration, and select portal profiles. This is where the magic happens. Customize, engage, and leave a lasting impression. The captive portal is the first page users see when connecting. You can customize the login form, registration page, terms of service, and branding images. Use admin portal, configuration, portal profiles to modify. Using registration and isolation workflows in PacketFence transforms how we manage network. The registration workflow is essential for onboarding unknown devices, ensuring they meet our security standards before gaining access. It's like a bouncer at a club, checking IDs to keep out troublemakers. On the flip side, the isolation workflow acts swiftly to block devices that violate our policies, such as those flagged for malware. This proactive approach not only protects our network, but also enhances the user experience by minimizing disruptions. Configuring these workflows within portal profiles and rules is straightforward, allowing us to tailor our security measures to fit our unique environment. By automating these processes, we not only bolster our defenses, but also streamline the onboarding experience for users. It's a win-win for security and usability. Using registration and isolation workflows in PacketFence. Registration workflow ensures unknown devices are properly onboarded. Isolation workflow blocks devices violating policies, like malware detection. You configure these workflows in portal profiles and rules. Automation improves network security and user experience. Using registration and isolation workflows in PacketFence transforms how we manage network security. PacketFence is a powerful tool that integrates seamlessly with intrusion detection systems like Snort or Suricata. Imagine a digital watchdog constantly monitoring network traffic for anything suspicious. IDS detect unusual activity, they send immediate alert at Fence. This is where the magic happens. PacketFence takes swift action, isolating or blocking the device in question, preventing potential threats from spreading. It's a security team that never sleeps, ensuring your network remains safe and sound. With this integration, you can trust that any abnormal behavior is swiftly addressed, keeping your environment secure and your peace of mind intact. PacketFence integrates with IDS like Snort or Suricata. IDS detects suspicious traffic, alerts PacketFence. PacketFence isolates or blocks the device. In PacketFence, managing security is all about understanding violation triggers and action profiles. When a potential threat is detected, these triggers spring into action, ensuring your network remains secure. Each violation is linked to an action profile that dictates the response. For instance, if a device is compromised, we can isolate it immediately, preventing any further risk. Alternatively, we might redirect the user to a portal for remission, guiding them through the necessary steps to regain compliance. And let's get the importance of communication. Notifying the administrator via email ensures that the right people are alerted and can respond swiftly. All of this is seamlessly configured in the policy section under violations. With PacketFence, just reacting to threats, you're probably managing your network's integrity. PacketFence uses violation triggers when threats. Each violation is an action profile. Isolate the device, redirect to portal, email administrator. Set up in configuration, policies, violations. Setting up guests with PacketFence is a breeze. Imagine welcoming visitors with a seamless experience. Create dedicated guest access portals for visitors to register themselves or set them up manually. The flexibility is fantastic. With options like SMS validation and email activation, you can ensure that only authorized guests gain access. Plus, if you want an extra layer of security, sponsor approval is right at your fingertips. Just navigate to Configuration, then Portal Profiles, and select Guest Access to customize everything to your needs. It's all about making the process smooth and ensuring your guests feel welcomed while keeping your network secure. With PacketFence, managing guest access has never been easier. Config-based VLAN assignment in PacketFence is a game changer for network management. Imagine this: guests automatically assigned to VLAN 10, while employees seamlessly connect to VLAN 20. It's all about defining roles in the GUI under configuration, then users, and finally roles. Once that's set, you link those roles to specifics in the network access configuration. This setup not only enhances network segmentation, but also gives you precise control over who accesses what. It's efficient, secure, and makes managing your network a breeze. Embrace role-based VLANs and elevate your network strategy. PacketFence empowers us to streamline role assignments effortlessly. Imagine a world where devices are automatically based on their MAC address, authentication status, or even device type. It's all about creating custom rules under configuration. Rules. For instance, if a device's host name starts with corp, it's instantly assigned the role. This not only simplifies access management, but also eliminates the need for tedious manual interventions. With these rules in place, we ensure that every device gets the right access, enhancing security and efficiency across the board. It's a game changer for network management. PacketFence simplifies network management by offering built-in DHCP and DNS services. To get started, to do is enable these features in your networks.conf. Just set DHCP enabled and named enabled. This configuration allows Packet to take charge of IP assignments and streamline redirection, ensuring a seamless experience. If you prefer, you can also integrate with an external DHCP server, giving you the ability to tailor your network setup to your needs. With these services activated, you'll enhance your network's efficiency and control, making it easier to manage devices and users' work. Audit logs are essential for tracking admin changes in PacketFence, and they provide a clear window to our network's configuration history. By navigating to the admin GUI and selecting Status, then Audit Logs, I can easily access a detailed record of every action taken. The filtering options are a game changer. I can sort by user, action type, or even specific dates. This level of granularity not only enhances accountability, but also serves as a vital reference point for any necessary rollbacks. If something goes awry, I can quickly pinpoint who made changes and when, ensuring our network remains secure and well managed. It's all about maintaining control and transparency in our operations. Audit logs are essential for tracking admin changes in PacketFence, and they provide a clear window into our network's configuration history. By navigating to the admin GUI and selecting Status, then Audit Logs, I can easily access a detailed. PacketFence makes generating system and security reports a breeze. Imagine having instant access to critical insights like authentication success rates, device violations, and register statistics, all at your fingertips. Just navigate to the Reports section, select the type of report you need, and hit Generate. It's that simple. Whether you're preparing for a security review or just keeping tabs on your network, these reports are invaluable. Plus, you can easily export your findings to CSV or PDF formats, making sharing and analysis a snap. With PacketFence, staying on top of your security game has never been easier. PacketFence makes generating system and security reports a breeze. Imagine having instant access to critical insights like authentication success rates, device violations, and registration statistics, all at your fingertips. Configuring email alerts and SMTP settings in PacketFence is crucial for staying on top of network events. First, navigate to Admin, then Configuration, and select System Settings. From there, head to the Mail section. Here you'll input your SMTP server details, including the port, sender email, and authentication credentials. Setup ensures that your alerts are sent promptly and securely.
Next, leverage alert profiles to define when emails should be triggered, especially during security violations. This way, your security team receives real-time notifications, allowing them to respond swiftly to potential threats. Keeping everyone informed is key to maintaining a robust security posture. Remember, timely alerts can make all difference in protecting your network.
Go to Admin, Configuration, System Settings, Mail. Set SMTP server, port, sender email, and auth. Use alert profiles to trigger emails when violations occur. Keep security teams informed in real time. A robust backup and restore all strategy for PacketFence is first, cron jobs to schedule all backups, ensuring that my data is consistently protected without manual intervention. Using the PF backup command, I generate comprehensive backups of the configuration and the database. This step is vital. It captures everything I need to restore my system in case of a failure. Next, I store these backups on a remote server or NAS. Adds an extra layer of security. This way, even if my local environment faces issues, my backups are safe and sound. With this strategy in place, disaster recovery becomes not just a possibility, but a fast and reliable process. I can breathe easy knowing my setup is secure and ready to bounce back at a moment's notice.
Setting up LED traps for real-time switch alerts in PacketFence is a game changer for network management. Imagine your switches actively notifying PacketFence critical events as they happen. To get started, configure your switch's SNMP receivers and point them to your PacketFence server's IP address.
This setup allows PacketFence to listen for important alerts like link up, down events, or port security breaches. The beauty of this system is its speed. You get immediate notifications, enabling you to react swiftly to network issues. With real-time alerts, you can maintain a robust network environment, ensuring minimal downtime and enhanced security. It's all about staying one step ahead in managing your network effectively. SNMP traps allow switches to notify PacketFence about events in real time. Configure SNMP trap receivers in your switch and point to the PacketFence server IP. PacketFence listens and reacts to trap link up, down, port security, etc. Helps with faster reaction to network events. Implementing MAC address bypass for known devices in PacketFence can streamline your network management significantly. Imagine a scenario where your printers or headless devices don't need to go through the hassle of registration or authentication every time they connect. It's simple. Just navigate to nodes, select new node, and enable the bypass option for the MAC addresses you want to allow. Once you've added the MACs, assign them a role and VLAN. This ensures they have seamless access to the network without unnecessary interruptions. It's a game changer for maintaining efficiency in your environment. By doing this, you're not just saving time, enhancing the user experience for everyone connected. So, take control of your network and make those known devices work for you. You can allow known MAC addresses to bypass registration or authentication. This is useful for printers or headless devices. Add MACs under nodes, new node, enable bypass. Assign a role and VLAN to allow seamless network access. In inline mode, PacketFence transforms into a powerful guardian of your network, leveraging firewall rules to inspect and filter packets with precision. Using tools like iptables or nftables, you can craft rules that allow redirect traffic based on roles or specific ports. Imagine having the ability to enforce security policies dynamically, granting access to trusted devices while blocking potential threats in real time. This level of control not only enhances visibility, but also empowers you to respond swiftly to any anomalies. With PacketFence in inline mode, you're not just monitoring traffic, you're actively the flow of data across the network, ensuring a robust defense against intrusions and vulnerabilities. It's about taking charge and making your network a fortress. In inline mode, PacketFence can inspect and filter packets via firewall rules. Use IP tables or NFT tables to allow, block, or redirect traffic. Rules can be role-based or port-specific. Inline mode gives PacketFence complete network visibility and control. In inline mode, PacketFence transforms into a powerful guardian of your network, leveraging firewall rules to inspect and filter packets with precision. Enabling wide controller support in PacketFence, game changer for network security. First, navigate to configuration and select. Here, you can easily add your wireless controller, whether it's Aruba, Cisco, or Ruckus. This integration allows you to manage your wireless infrastructure just like any other switch, streamlining management. Next, don't forget to enable wireless roles and portal access profiles. This step is crucial for providing seamless Wi-Fi security. With these roles, you can define user access levels and ensure that every device connecting to your network is authentic and secure. By leveraging PacketFence's capabilities, you're not just enhancing security, you're also simplifying the user experience. It's all about creating a robust, secure environment while keeping things user-friendly. So, dive in and make your wireless network as secure as it can be. Advanced mapping using radius attributes in PacketFence is a game changer for network management. Imagine being able to assign different VLAN user groups seamlessly. With just a few clicks, you can set up attribute mappings in configuration, users, radius, attributes. This allows for precise control over access to what, if your network remains secure and efficient. By leveraging these radius attributes, you can implement advanced identity-based access control, tailoring the user experience to fit specific needs. Whether it's granting guest access or restricting sensitive areas to certain user roles, the flexibility is incredible. This not only enhances security, but also optimizes network performance. So, dive into PacketFence and start mapping those roles like a pro. Advanced role mapping using radius attributes in PacketFence is a game changer for network management. Imagine being able to assign different VLANs based on user groups seamlessly. Configuring radius for attribute-based VLAN assignment is straightforward. First, navigate to Users, then Sources, and select Radius. Once there, edit your source and enable attribute mapping. This is where the magic happens. Define your attribute filter. For instance, set it to Tunnel Private Group ID, Hardware 30. This tells the system which VLAN to assign based on the user's group ID. Next, map this attribute to a specific PacketFence role that aligns with your network policies. It's crucial to ensure that the roles are correctly defined to avoid any access issues. Finally, save your changes and test the configuration with a client device. Watch as the VLAN assignment works seamlessly, ensuring users are placed in the right network segment. This setup not only enhances security, but also optimizes network performance. Monitoring real-time device connections in the PacketFence dashboard is a game changer for network management. Just navigate to Admin GUI, then Status, and click on Connected Nodes. Instantly, you'll see a comprehensive list of devices, everything from hostname, IP, MAC address to their role and current status. What's really powerful is the filtering options. You can narrow down your view by VLAN, switch, or even specific violations. This feature is invaluable for tracking who's on the network live. Whether it's identifying unauthorized devices or ensuring compliance, having information at your fingertips allows for quick decisioning. Stay proactive and keep your network secure by leveraging these insights. It's all about knowing who's connected and maintaining control over your environment. Monitoring real-time device connections in the PacketFence dashboard is a game changer for network management. Creating and managing admin in the PacketFence interface is straightforward and essential for maintaining security. To add a new admin, simply navigate to Admin and select Administrators. Here, you can assign roles like Read-Only, Op, or Super Admin. Take access based on responsibilities. But it doesn't stop there. You can enforce robust password policies to ensure strong credentials and implement two-factor authentication, extra layer of security. This not only protects sensitive data, but also keeps admin activities secure and auditable. By managing your admin users effectively, you create a safer environment for everyone involved. Remember, a well-structured admin is key to a successful PacketFence deployment. Enabling wireless controller support in PacketFence is a game changer for your network security. Start by navigating to Configuration and then Network, where you can seamlessly add your wireless controller, whether it's Aruba, Cisco, or Ruckus. This integration allows you to treat your wireless controller just like a switch, enhancing your overall infrastructure. Next, don't forget to enable wireless roles and portal access profiles. This step is crucial for ensuring that your Wi-Fi security is robust and effective. With these settings in place, you'll provide a secure and user-friendly experience for all your wireless users. It's all about creating a seamless connection while maintaining top-notch security. So dive in, configure those settings, and watch your network thrive. Enabling wireless controller support in PacketFence is a game changer for your network security. Start by navigating to Configuration and then Network, where you can seamlessly add your wireless controller, whether it's Aruba, Cisco, or Ruckus. This integration allows you to treat your wireless controller just like a switch, enhancing your overall infrastructure. Advanced role mapping using radius attributes in PacketFence is a game changer for network management. Imagine being able to assign different VLANs based on user groups seamlessly. With just a few clicks, you can navigate to Configuration, then Users, and finally Radius Attributes. Here, you can set precise attribute mappings that ensure users get the right access based on their roles. This means that whether you're a guest, an employee, or an admin, your network experience is tailored just for you. It's all about advanced identity-based access control, enhancing security while simplifying user management. With PacketFence, you're not just managing users, you're optimizing the entire network experience. Advanced role mapping using radius attributes in PacketFence is a game changer for network management. Imagine being able to assign different VLANs based on user groups seamlessly. Managing admin access levels in PacketFence is crucial for maintaining security and efficiency. You have 3 roles to choose from: read-only, operator, and super admin. Each role serves a specific purpose. For instance, a read-only admin can view settings but can't make changes, which is perfect for audits. Operators can manage daily tasks without the risk of altering critical configurations. Super admins have full control, but with great power comes great responsibility. To set these roles, simply navigate to Admin. Administrators. Here, you can add or edit users and define their access to different sections. This targeted approach helps limit misconfigurations and enforces the principle of least privilege. By carefully managing who can do what, you enhance your network security and ensure that only the right people have the right access. Remember, a well-structured admin hierarchy is key to a secure and efficient PacketFence environment. Managing admin access levels in PacketFence is crucial for maintaining security and efficiency. You have 3 roles to choose from: read-only, operator, and super admin. Each role serves a specific purpose. PacketFence provides a powerful suite of REST APIs that seamlessly integrate with various external systems like SIEMs, ticketing tools, and inventory management systems. Imagine being able to query nodes, track violations, and manage users with just a few lines of code. It's all possible with PacketFence. To get started, head over to the API documentation located at SOICUSR local pf-doc web services. This resource is your roadmap to harnessing the full potential of PacketFence. Remember, security is key. Always use tokens for API authentication to keep your data safe. With these APIs, you can automate workflows, enhance visibility, and streamline operations across your network. The integration possibilities are endless, making your systems more efficient and responsive. Dive in and start transforming how you manage your network today. Automating node cleanup in PacketFence is a game changer for managing your network. By navigating to Configuration, Settings, Node Cleanup, you can set expiration policies that automatically remove stale nodes. Imagine this. Guest devices that haven't been active for a set number of days will be auto-expired, keeping your database lean and organized. This not only reduces clutter, but also enhances performance. Plus, it saves you time. No more manual checks or cleanups. Just set it and forget it. With these automated policies, you can focus on what really matters, optimizing your network and ensuring a seamless experience for your users. Embrace automation and let PacketFence do the heavy lifting for you. Active portal redirect handling is crucial for mobile devices and BYOD environments. When PacketFence detects an operating system, it intelligently adjusts the redirection process. This is especially important for mobile operating systems like iOS and Android, which often require special user agent handling. By enabling smart redirect logic in the portal profile, we can streamline the user onboarding experience. Imagine a seamless connection where users are guided effortlessly through the authentication process, reducing frustration and increasing satisfaction. This not only enhances security, but also fosters a more efficient network experience. With the right setup, we can ensure that every device, regardless of its OS, gets the tailored support it needs to connect smoothly. Captive portal redirect handling is crucial for mobile devices and BYOD environments. When PacketFence detects an operating system, it intelligently adjusts the redirection process. In PacketFence, user roles are the backbone of our network access control. Think of them as the gatekeepers that determine who gets in and what they can do once they're connected. Each role is crafted to define specific authorization policies, allowing administrators to tailor access based on identity, device type, or even security posture. This means a guest device might only get internet access, while a corporate laptop could have full access to sensitive resources. It's all about dynamic segmentation, ensuring that the right users and devices have the right level of access at the right time. With PacketFence, managing network access becomes not just efficient, but also secure. Adapting to the ever-changing landscape of our digital environment, PacketFence ensures that the right users and devices have the right level of access at the right time. In PacketFence, user roles are the backbone of our network access control. User roles in PacketFence access control are crucial for managing network security and access. Each role defines specific permissions, tailoring the experience based on the user's needs. For instance, a guest role is designed for limited access, allowing only internet connectivity, perfect for visitors who need to browse without compromising the network. On the other hand, a staff role opens the door to internal resources, enabling employees to access sensitive data and applications essential for their work. Then we have the quarantined role, which is a safety net that restricts all access except to remediation servers. This ensures that any device posing a risk can be isolated and addressed without jeopardizing the entire network. By clearly defining these roles, PacketFence not only enhances security, but also streamlines user experience, making sure everyone has the right level of access. User roles in PacketFence access control are crucial for managing network security and access. Each role defines specific permissions, tailoring the experience based on the user's needs. Role assignment in network security is crucial for ensuring that the right users have the right access. It starts with authentication credentials like LDAP, Radius, or SAML, which verify who you are. But it doesn't stop there. Imagine a device's MAC address acting as a digital fingerprint, or device posture checking if your antivirus is up to date and your OS is patched. Time of day can also play a role. Maybe you only need access during business hours. And let's not forget location. Whether you're connecting through a specific switch port or SSID can determine your permissions. Custom logic, like radius attributes or SQL queries, adds another layer, allowing for tailored access based on unique organizational needs. Each of these factors works together to create a dynamic and secure environment, ensuring that access is not just granted, but intelligently managed. Role assignment in network security is crucial for ensuring that the right users have the right access. It starts with authentication credentials like LDAP, radius, or SAML, which verify who you are. In the PacketFence administration interface, role mapping rules are essential for managing user and device access. These rules evaluate specific information and assign roles based on multiple conditions, allowing for prioritized decision-making. Imagine a scenario where a device fails a compliance check, like having outdated antivirus software. With role mapping, that device can be isolated automatically, ensuring network security. Now, think about BYOD devices. They often need limited access to protect corporate resources. PacketFence seamlessly integrates with VLANs and firewalls, dynamically enforcing policies that keep your network safe. VoIP phones, printers, and IoT devices can be placed in isolated roles, ensuring they don't compromise security. Meanwhile, known corporate devices enjoy full access, streamlining productivity. This intelligent role mapping not only enhances security, but also optimizes network performance, making it a game changer for any organization. In the PacketFence administration interface, role mapping rules are essential for managing user and device access. These rules evaluate specific information and assign roles based on multiple conditions, allowing for prioritized decision-making. Configuring parent ACL's PacketFence is essential for defined network access levels for authenticated devices. First, navigate to the ACL section in the PacketFence interface. Here, you can create a new parent ACL by specifying the name and description. Next, set rules that dictate access permissions. Think of these as the gatekeepers of your network. You'll want to integrate radius attributes to ensure that the right users get the right access based on their roles. Don't forget to link your parent ACL to the appropriate VLANs. This is crucial for segmenting your network effectively. Finally, apply these settings to your switches or controllers to enforce your policies. With these steps, you're not just configuring access, you're shaping a secure network environment tailored to your organization's needs. To set up a robust network security solution with PacketFence, you need a few key components. First, ensure you have a functioning PacketFence installation. This is your foundation, the heart of your network access control. Next, you'll need a switch or controller that supports ACLs. Think Cisco or Aruba. These devices are crucial for enforcing your access policies and managing traffic effectively. Lastly, having administrator access to PacketFence is essential. This access allows you to configure settings, manage devices, and respond to security incidents in real time. With these prerequisites in place, you're ready to enhance your network security and streamline user access. Defining access control lists, or ACLs, on your switches and controllers is crucial for maintaining network security. Think of ACLs as the gatekeepers of your network, determining who gets in and who stays out. When configuring ACLs, you need to specify rules based on IP addresses, protocols, and ports. For instance, you might allow HTTP traffic from your internal network while blocking all external access to sensitive resources. Remember, PacketFence doesn't push these ACLs directly. It relies on the configurations you've set up. So, it's essential to ensure your ACLs are correctly defined and regularly updated to adapt to new threats. Always test your ACLs in a controlled environment before deploying them live. This way, you can avoid accidentally locking out legitimate users or services. A well-defined ACL not only enhances security, but also optimizes network performance by reducing unnecessary traffic. Keep your network safe and efficient with precise ACL configurations. Configuring switches in PacketFence is straightforward but crucial for network security. First, navigate Configuration, then Network, and select Switches. Here you can either edit an existing switch or add a new one. Ensure that radius attributes are enabled. This is vital for authentication and accounting. If your network requires it, don't forget to enable Change of Authorization or COA. This feature allows you to dynamically adjust access permissions without needing to disconnect users. Lastly, check that you've specified ACL support in your switch template or set it up manually. This ensures that your access control lists are properly enforced, enhancing your network's security posture. With these settings in place, your switches will be well configured to support a robust and secure network environment. Configuring switches in PacketFence is straightforward but crucial for network security. First, navigate to Configuration, then Network, and select Switches. In PacketFence, ACLs play a crucial role in managing network traffic efficiently. Think of the foundation for your access control lists. A parent ACL contains common rules that apply to multiple devices, like allowing and DHCP traffic. This means you set up these essential permissions once, and they automatically apply to any child ACLs that inherit. Now, a child ACL can build on this foundation specific rules tailored to particular needs, such as allowing web access to certain domains. This hierarchical structure not only simplifies management, but also enhances security by ensuring consistent rules across your network. In parent and child ACLs effectively, you can streamline your network policies and maintain robust security posture. In PacketFence, Parent ACLs play a crucial role in managing network traffic efficiently. Think of them as the foundation for your access control list. A parent ACL contains codes that apply to multiple devices, like allowing DNS and DHCP traffic. This means you set up these essential permissions once, and they automatically apply to any child ACLs that inherit from it. To configure ACLs in PacketFence, first, log into the web interface. Navigate to Configuration, then Policies, and select ACLs. Here, click on Add ACL to create a new one. I like to name mine something descriptive, like Parent Common Services. This helps keep things organized. Now it's time to add rules. For instance, allow port 53 for DNS to ensure name resolution works smoothly. Don't forget to include port 67 and 68 for DHCP, crucial for dynamic IP address assignments. Once you've added all your necessary rules, make sure to save the ACL. And just like that, you've set up a parent ACL that enhances your network security and functionality. To configure parent ACLs in PacketFence, first, log into the web admin interface. Navigate to Configuration, then Policies, and select ACLs. Here, click on ACL to create a new one. Integrated finger bank with PacketFence transforms the way we approach device profiling. Imagine having the ability to create dynamic access control lists based on the unique characteristics of each device on your network. This integration doesn't just streamline access. It enhances security by implementing role-based access control. Each device is assessed in real time, allowing us to detect anomalies and respond swiftly to potential threats. With this powerful combination, we can ensure that only authorized users have access to sensitive resources, adapting to the ever-evolving landscape of cybersecurity. It's not just about control, it's about creating a safer, smarter network environment for everyone. Integrating FingerBank with PacketFence transforms the way we approach device profiling. Imagine having the ability to create dynamic access control lists based on the unique characteristics of each device on your network. In the world of network management, the concept of inherit VLAN in PacketFence is a game changer. Imagine a device that seamlessly retains its VLAN assignment even as it roams or reconnects. This means no more disruptive VLAN changes during authentication or policy updates. It's all about maintaining a stable connection, especially for devices that frequently switch networks. By allowing endpoints to inherit their previous VLAN, we enhance user experience and minimize service interruptions. This is crucial in environments like schools or offices where devices are constantly on the move. The result? A smoother, more efficient network that keeps users connected without the hassle of constant reconfiguration. Inherit VLAN is not just a feature. It's a smart solution for modern networking challenges. When configuring roles in PacketFence, you'll often come across the Inherit VLAN option. This feature is crucial for managing network access effectively. Imagine you're defining a role under configuration, policies, and access control. You have the choice to assign a specific VLAN or an access control list. But what does Inherit VLAN really mean? It's simple. By selecting this option, the device retains its previously assigned VLAN. This can streamline your network management, ensuring devices maintain their established connections without unnecessary disruptions. It's all about efficiency and consistency in your network policies. So, when in doubt, consider the power of inheritance. Using Inherit VLAN can be When it comes to managing network security, there are critical moments when you should avoid using certain strategies. For instance, if your policy mandates that devices must be explicitly moved to quarantine, registration, or production VLANs, then sticking to that protocol is essential. It's not just about keeping things organized, it's about maintaining a secure environment. Also, consider access levels tied to VLAN assignments. If you have distinct VLANs for guests and employees, mixing those up can lead to serious security breaches. Imagine a guest accessing sensitive employee data. It's a nightmare scenario. So always remember, clarity in VLAN assignments is key to safeguarding your network. Stay vigilant and ensure that your policies. When it comes to managing network security, there are critical moments when you should avoid using certain strategies. For instance, if your policy mandates that devices must be explicitly moved to quarantine, registration, or production VLANs, then sticking to that protocol is essential. When you define a parent role, like student, and then create a child role, such as staff, you unlock a powerful inheritance system. The staff role automatically inherits all the access control lists and policies from the student role. This means you don't have to reinvent the wheel every time you create a new role. Instead, you can focus on adding any specific rules or ACLs that are unique to staff. This streamlined approach not only reduces duplication, but also makes policy management a breeze. Imagine the time saved and the clarity gained. By structuring roles this way, you ensure consistency across your organization while maintaining the flexibility to adapt as needed. It's a win-win for efficiency . To configure role inheritance, start by defining your parent role. Navigate to Configuration, then Policies, and select Roles. Here, you can create or edit a role, like the student role. Make sure to set the appropriate ACLs, VLANs, or firewall rules that fit your needs, and don't forget to save changes. Next, it's time to create the inheriting role or the child role. In the same Roles section, click on Add Role. Name this role, for example, Staff Role. In the Parent Role drop-down, select the student role you just created. This step is crucial because it allows Staff Role to inherit all the permissions of student role. You can then add any specific rules or ACLs that apply only to the Staff Role. Once you've tailored it to your needs, save the role. Now, you've successfully set up role inheritance, streamlining your permissions management. To configure role inheritance, start by defining your parent role. Navigate to Configuration, then Policies, and select Roles. Here, you can create or edit a role, like the student role. When a user is assigned the staff role in PacketFence, the magic begins. First, the system applies the student role ACLs and policies through inheritance. This means that the user automatically gains access to essential services like DNS, DHCP, and web access. But it doesn't stop there. Next, any additional ACLs defined in the staff role come into play, adding SSH and FTP access to the mix. What's fascinating is how PacketFence prioritizes these rules. If there's any overlap, the child role rules take precedence. So, for a device in the staff role, it seamlessly combines the student privileges with the enhanced staff permissions. The result? A powerful blend of access that ensures users have what they need to perform their roles effectively. It's a smart, efficient way to manage network access, keeping everything organized and secure. Integrating Active Directory with Integrating Active Directory with PacketFence is a straightforward process, but it's crucial to ensure you have the right prerequisites in place. First, make sure your PacketFence server can communicate with the AD server. This typically means having network access on port 389 for LDAP or port 636 for LDAPS. Next, you'll need valid AD credentials, specifically a bind user with read access. This is essential for PacketFence to pull the necessary information from Active Directory. Lastly, don't overlook DNS configuration. Your PacketFence server must be able to resolve the domain controller's hostname. With these steps in check, you're well on your way to a successful integration. Integrating Active Directory with PacketFence is a straightforward process, but it's crucial to ensure you have the right prerequisites in place. Configuring the active In PacketFence, a realm is essential for directing authentication requests to the right source, whether it's Active Directory, LDAP, or Radius. Imagine a user logging in with an email like userschool.edu. The realm recognizes that format and knows exactly where to send that request. This capability is crucial for organizations with multiple authentication backends, allowing them to manage various Active Directory forests or even different companies seamlessly. It simplifies complex environments, making multi-tenant or multi-domain setups a breeze. With Realms, PacketFence ensures that every login request is routed efficiently, enhancing security and user experience across the board. Imagine a world where two distinct Active Directory domains coexist seamlessly. On one side, we have corp.local, where users like Aravind log in with aravinducorp.local. His credentials are authenticated through the Corp AD, ensuring he has access to all the resources he needs for his corporate tasks. On the flip side, there's school.edu, where Aravind1 logs in as aravinduschool.edu. Her authentication is handled by the school AD, granting her access to educational resources tailored for her studies. This setup not only enhances security, but also streamlines user experience. Each domain operates independently, yet they can communicate when necessary, allowing for collaboration without compromising security. It's a perfect balance of efficiency and protection, ensuring that both Aravind and Aravind One can thrive in their respective environments without any hiccups. This is the power of managing multiple AD domains effectively. Configuring realms in PacketFence is straightforward and essential for managing your authentication sources effectively. First, navigate to Configuration, then Authentication Sources, and select Directory. Here, you'll add each Active Directory or LDAP server as its own source. Name them clearly, like CorpAd for your corporate directory and SchoolAd for your educational institution. Next, it's time to create the realms. Head over to Configuration, then Authentication Sources, and click on Realms. Click Add Realm and fill in the details. For instance, for your corporate realm, use the name corp.local and the suffix acorp.local. Make sure to select the corresponding authentication source, which is CorpAd. If you want to streamline the process, you can enable the strip suffix option to remove acorp.local before sending credentials to AD. Repeat this process for your educational realm using school.edu linked to SchoolAd. Finally, to ensure everything is working smoothly, go to Users and select Test Authentication. Try logging in with usericorp.local and useriSchool.edu. This will confirm that each login routes to the correct authentication backend. Simple, right?
When managing user logins, setting a default realm is crucial for those who might not have a domain suffix. This ensures a seamless experience for everyone. Now, if your Active Directory doesn't require the domain suffix and usernames, the strip realm option becomes a game changer.
It simplifies the login process, making it more user-friendly. Let's not forget about connection profile mapping. This feature allows you to tie specific realms to designated connection profiles, giving you greater control over user access. By customizing these settings, you can enhance security and streamline user management. It's all about creating a smooth, efficient login experience while keeping everything secure and organized. When managing user logins, setting a default realm is crucial for those who might not have a domain suffix. Ensure a seamless experience for everyone. In PacketFence, authentication sources are the backbone of user credential validation. Imagine a world where your access policies and roles hinge on the strength of these sources. Whether it's Active Directory, LDAP, Radius, SQL databases, or even local files, each plays a crucial role in ensuring security and efficiency. Active Directory streamlines user management, while LDAP provides a flexible directory service. Radius adds an extra layer of security for remote access, and SQL databases offer robust data handling capabilities. Local files, though simpler, can be a quick solution for smaller setups. Understanding these sources is essential. They not only validate who you are, but also dictate what you can access. In the realm of network security, knowing your authentication sources means knowing your power. In PacketFence, Authentication sources are the backbone of user credential validation. Imagine a world where your access policies and roles hinge on the strength of these sources. In the world of PacketFence, authentication sources play a crucial role in securing network access. First up, we have Radius, a robust choice that centralizes user authentication, making it easier to manage credentials across multiple devices. Then there's LDAP, which integrates seamlessly with directory services, allowing for efficient user management and streamlined access control. Don't forget about Active Directory, a favorite in many organizations for its compatibility with Windows environments, enabling single sign-on for users. For those looking for flexibility, TACACS Plus offers granular control over user permissions, perfect for environments with diverse access needs. And let's not overlook the power of local authentication, which provides a fallback option when external sources are unavailable. Each of these sources has its strengths, and choosing the right one can significantly enhance your network security while ensuring a smooth user experience. In the world of PacketFence, authentication sources play a crucial role in securing network access. First up, we have Radius, a robust choice that centralizes user authentication, making it easier to manage credentials across multiple devices. Configuring authentication sources in PacketFence is straightforward. First, navigate to the web admin interface and head to Configuration, then Authentication Sources. Click Add to create a new source. If you're using Active Directory via LDAP, enter the name as corpad. Set the server to add.corp.local and choose the appropriate port, 389 for LDAP or 636 for LDAPS. For the base DN, input dsiege corp, dsiege local, and for the bind DN, use cnpadmin cn users, dsiege corp, dsiege local. Don't forget to enter your bind user's password. For the user filter, use the syntax and object class user, some account name percentis, to ensure proper user identification. After testing the connection, save your settings. If you prefer using a local database, simply select Local and manage users under Users, Local Users. That's it. You're all set to manage authentication sources effectively. Setting the authentication order is crucial for managing user access effectively. First, navigate to Configuration, then Authentication Sources, and select Sources. Here, you can easily drag and drop to prioritize your authentication methods. Want local users to be authenticated before LDAP? Just move it up the list. Prefer LDAP to take precedence over Radius? You can do that too. Once you've set your priorities, it's time to assign these sources to your connection profiles. Head over to Configuration, then Policies, and select Connection Profiles. Under Authentication Sources, you can specify which sources apply to each profile, whether it's for the guest portal or your internal network. This ensures that the right users are authenticated in the right way, enhancing both security and user experience. It's all about making your authentication process as efficient as possible. Setting the authentication order is crucial for managing user access effectively. First, navigate to Configuration, then Authentication Sources, and select Sources. Here, you can easily drag and drop to prioritize your authentication methods. Managing user authentication, combining sources with realms can streamline the process significantly. Imagine a scenario where a user logs in with an email like user@school.edu. With realms configured, PacketFence automatically routes this user to the school ad authentication source. Similarly, if a user logs in with usercorp.local, they're directed to the corp ad source. This setup not only enhances security, but also simplifies user management. Now, testing authentication is a breeze. By navigating to users and selecting Test Authentication, you can enter a username and password to see exactly which authentication source was utilized. It's clear and immediate. PacketFence shows you the success or failure reason right away, along with any matched roles. This level of transparency not only boosts confidence in the system, but also allows for quick troubleshooting. With Realms, managing diverse authentication needs becomes a seamless experience. When managing user authentication, combining sources with Realms can streamline the process significantly. Imagine a scenario where a user logs in with an email like userschool.edu. With Realms configured, PacketFence automatically routes this user to the school ad authentication source. Network switches play a crucial role in integrating with PacketFence for effective network access control. When a device connects to a network, the switch identifies it and communicates with PacketFence to determine its compliance with security policies. This dynamic interaction allows PacketFence to enforce rules such as VLAN assignments or access restrictions based on the device's status. For instance, if a device is not compliant, the switch can automatically place it in a quarantine VLAN, isolating it from critical resources while notifying the network administrator. This real-time response not only enhances security but also streamlines the user experience, allowing compliant devices to access the network seamlessly. Moreover, PacketFence utilizes Radius for authentication, enabling switches to enforce policies consistently across the network. This integration ensures that every device is vetted before gaining access, creating a robust defense against unauthorized access. In essence, the synergy between network switches and PacketFence transforms network access control into a proactive, automated process that safeguards organizational assets. In a packet PacketFence communicates with switches using several key methods. First up is SNMP, which is essential for monitoring port control. It's best to use SNMP v3 for its enhanced security features. Then we have the CLI accessed via SSH or Telnet, which is still used for some legacy operations like port bouncing, though it's becoming less common in modern setups. Radius plays a crucial role too, especially for 802.1x authentication, MAC authentication bypass, and dynamic VLAN assignments. Just remember, Radius needs to be configured on both the switch and PacketFence for seamless operation. Lastly, we can't overlook SNMP traps and Radius change of authorization. These allow for real-time changes in authorization, making inline enforcement a breeze. Each method has its purpose, ensuring that network management is efficient and secure. PacketFence communicates with switches using several key methods. First up is SNMP, which is essential for monitoring and port control. It's best to use SNMP v3 for its enhanced security features. PacketFence offers a range of switch enforcement modes that enhance network security and user experience. First up, we have VLAN enforcement, where switch ports are dynamically assigned to specific VLANs like registration, quarantine, or production. This ensures that users are placed in the right environment based on their status. Next, there's Radius Dynamic ACLs. This mode pushes access control lists based on user roles, perfect for switches like Cisco iOS or Aruba. It allows for granular control over what users can access, adapting to their needs in real time. Then we have inline enforcement, where PacketFence sits between the user and gateway, effectively controlling traffic with inline bridges. This mode is fantastic for isolating users until they meet compliance. Finally, the hybrid mode combines the best of both worlds, using inline for isolation while leveraging VLANs and ACLs for seamless production access. Each mode offers unique advantages, ensuring your network remains secure while providing flexibility for users. PacketFence offers a range of switch enforcement modes that enhance network security and user experience. First up, we have VLAN enforcement, where switch ports are dynamically assigned to specific VLANs like registration, quarantine, or production. This ensures that users are placed in the right environment based on their status. Next, there's Radius Dynamic ACLs. This mode pushes access control lists based on user roles, perfect for switches like Cisco iOS or Aruba. It allows for granular control over what users can access, adapting to their needs in real time. When troubleshooting VLAN issues, the first step is to check if the device is switching VLANs correctly. If it's not, look into your SNMP community settings and ACLs. Port security might be blocking the switch, so ensure your VLAN configuration is spot on. If authentication is failing, dive into the Radius logs. Those Radius.log files can reveal if the shared secret is mismatched. Now, if your switch isn't sending traps, double-check that the SNMP trap destination is configured properly. Sometimes a firewall might be blocking those traps, so keep an eye on that. And if you're not seeing a MAC address detected, you need to verify if SNMP is functioning. Checking the pfDetect logs can provide insights into what's going wrong. Each of these steps is crucial for a smooth network operation, so don't overlook them. In PacketFence, compliance in PacketFence is all about ensuring that devices meet specific security standards before they can access the network. Think of it as a digital bouncer checking IDs. For a device to be deemed compliant, it must have a few key elements in place. First, antivirus software needs to be installed and up to date, acting as the first line of defense against threats. Next, the operating system must be patched, closing any vulnerabilities that could be exploited. A firewall should be enabled, providing an additional layer of protection. It's also crucial that no blacklisted software is lurking on the device, as that could pose serious risks. Lastly, being part of a domain like Active Directory is essential for maintaining control and security. In essence, PacketFence's compliance system ensures that only secure, well-maintained devices can join the network, keeping everyone safe from potential threats. PacketFence offers robust compliance checks through two primary methods. First, there's the agent-based compliance using the PacketFence agent, available for Windows, Mac OS, and Linux. This handy tool scans your device for critical elements like antivirus presence, OS version, registry values, running processes, and installed software. If your device doesn't meet the compliance standards, it gets redirected to a remediation VLAN, no exceptions. On the other hand, we have agentless compliance, which utilizes SNMP, Nmap, or NAC posture from 802.1x or Radius accounting. While this method is less detailed, it's perfect for IoT and legacy devices that might not support an agent. Even without deep insights, it can still trigger isolation or remediation based on basic profiles. PacketFence ensures that your network remains secure and compliant, no matter the device type. PacketFence offers robust compliance checks through two primary methods. First, there's the agent-based compliance using the PacketFence agent, available for Windows, Mac OS, and Linux. This handy tool scans your device for critical elements like antivirus presence, OS version, registry values, running processes, and installed software. If your device doesn't meet the compliance standards, it gets redirected to a remediation VLAN, no exceptions. Imagine this. Your device connects to the network, whether it's wired or wireless. Instantly, authentication kicks in. Think 802.1x, MAC filtering, or a captive portal. Once authenticated, PacketFence steps in, assigning a role to your device and, if needed, requesting posture information. Now here's where it gets interesting. PacketFence checks compliance rules. If your device meets all the requirements, congratulations. you gain access to the production VLAN. But if it doesn't comply, it's redirected to a remediation VLAN, where you'll find clear instructions on how to fix the issues. Once you've made the necessary adjustments, your device gets reevaluated. If it passes the compliance check this time, it's back to production VLAN, ready to roll. This streamlined workflow ensures a secure network while keeping things efficient and user-friendly. When it comes to compliance rules for our systems, there are a few key points to keep in mind. First, we need to ensure that every device is running Windows 10 or newer. This is crucial for security and compatibility. Next, Windows Defender must be active. It's our first line of defense against threats. Then, let's talk browsers. Both Firefox and Chrome need to be up to date. Outdated browsers can be a gateway for vulnerabilities, so regular updates are non-negotiable. Lastly, we can't overlook malware. A thorough check for known malware, whether through processes or registry entries, is essential. Keeping our systems clean and secure isn't just a rule, it's a commitment to protecting our data and integrity. Stay compliant, stay secure. FingerBank is a fascinating open-source project that takes device fingerprinting to the next level. Developed by Inverse, the creators of PacketFence, it leverages network characteristics to accurately profile devices. Imagine this. When a device connects to a network, FingerBank analyzes various elements like DHCP fingerprinting, which looks at the option code sent in DHCP requests. It also examines HTTP user agent strings, the MAC address OUI, and even TLS fingerprints in its newer versions. Once PacketFence collects these fingerprints, it sends them to FingerBank, which then responds with a specific device type and a confidence score. This means you could identify a device as a Windows 11 laptop, an iPhone 14, or even a Samsung TV, all based on its unique network behavior. It's a powerful tool for network security and management, making it easier to understand what devices are on your network and how to protect them. The precision and reliability of FingerBank truly showcase the potential of open-source technology in enhancing our digital environments. FingerBank is a fascinating open-source project that takes device fingerprinting to the next level. Developed by Inverse, accurately profile devices. When a device connects to network, whether wired or wireless, PacketFence springs into action. It collects crucial data like DHCP request options, the MAC address OUI, and even the HTTP user agent if a web request is made. This information is then sent to the FingerBank API either locally or in the cloud. FingerBank processes this data and returns key insights: the device type, like an Android phone or an HP printer, the operating system, and a confidence score that tells us how sure we can be about this identification. With this intelligence, PacketFence can assign roles such as IoT, mobile, BYOD, or corporate device, ensuring that each device is treated appropriately. It enforces policies or VLANs based on the device type and can even trigger actions like isolation or registration. This seamless integration helps maintain a secure and efficient network environment. Imagine a world where your network instantly recognizes every device connected to it. With FingerBank profiling, this is reality. Picture this. Your smart TV, security cameras, and even printers are automatically identified and isolated, ensuring seamless connectivity. No more guessing games. Now think about MAC authentication fallback profiling. It allows us to classify devices like printers versus laptops using just DHCP data. This means we can assign specific roles, like mobile device or managed laptop, based on their behavior and characteristics. And let's not forget security policy enforcement. We can block known vulnerable devices, like those outdated XP machines, from accessing our network. This proactive approach not only enhances security, but also keeps our digital environments safe and efficient. Fingerbank profiling transforms how we manage and protect our IoT landscape, making it smarter and more secure. Fingerbank device change detection in PacketFence is a game changer for network security. Imagine a scenario where a device suddenly changes its profile. This could mean a spoof device is trying to sneak in, like someone using Mac spoofing to bypass our defenses. Or maybe it's a compromised endpoint, putting sensitive data at risk. With this feature, we gain heightened visibility into our network. It doesn't just alert us to suspicious behavior, it can trigger immediate actions to mitigate potential threats. This proactive approach ensures that we stay one step ahead of anyone trying to exploit vulnerabilities. In a world where security breaches are all too common, Fingerbank is our vigilant. The Fingerbank device change detection in PacketFence is a game changer for network security. Imagine a scenario where a device suddenly changes its profile. This would mean a spoofed device trying to sneak in, like someone using Mac spoofing to bypass our defenses. Device change detection is a crucial feature in network security, and it's all about keeping your environment safe. Imagine a device connecting to your network. PacketFence continuously profiles it using Fingerbank, analyzing DHCP, MAC OUI, and HTTP headers. Now, if that device suddenly presents a new fingerprint that doesn't match its stored profile, PacketFence springs into action. First, it logs the change, ensuring there's a record of what happened. Then, it alerts the administrator, so they're in the loop and can take necessary actions. Depending on the configuration, the device might be moved to a quarantine or limited access VLAN, restricting its capabilities. In some cases, access can be denied completely. This proactive approach not only protects your network, but also helps maintain the integrity of your data. Device change detection is like having a vigilant security guard, always on the lookout for anything unusual. Device change detection is a crucial feature in network security, and it's all about keeping your environment safe. Imagine a device connecting to your network. Imagine this. Device A, a Windows 11 laptop, connects to the network for the first time. Fingerbank springs into action, identifying it and saving its profile under the MAC address. Fast forward to later, and suddenly, a different fingerprint pops up from the same MAC. This time, it's an Android phone. Now, that's a red flag. Fingerbank detects this change as suspicious, triggering PacketFence to log the anomaly. It flags the device for admin attention, ensuring that no unauthorized access slips through the cracks. Depending on the settings, it might even move that device to a remediation VLAN, isolating it until the issue is resolved. This proactive approach keeps networks secure and ensures that only trusted devices are allowed in. It's all about maintaining integrity in a world where devices are constantly changing. To enable device change detection in PacketFence, first, we need to focus on Fingerbank profiling. Navigate to Configuration, then Fingerbank and its settings. Here, make sure Fingerbank is enabled, whether you're using the cloud or local option. You can also set thresholds for matching competence to fine-tune how strict you want the detection to be. Next, let's move on to enabling device change detection itself. Head over to Configuration, then Policies, and select Settings. Look for the device fingerprint change detection option and set it to enabled. This is crucial for monitoring any changes in device fingerprints. You can also customize the action taken on a fingerprint mismatch. Whether you want to log the event, trigger NMP traps, send email alerts, or log it to syslog, the choice is yours. This way, you'll stay informed and can respond quickly to any unexpected changes. When it comes to Fingerbank device change positives, especially from guest or IoT VLANs, which can clutter your alerts. In PacketFence, encountering a new finger bank combination is like discovering a hidden gem in device identification. Imagine a device connecting to your network with a unique mix of attributes, like its DHCP options, user agent string, and MAC OI that you've never seen before. This is where PacketFence shines. When it detects this unfamiliar fingerprint, it doesn't just shrug it off. Instead, it logs the event, flags the device for further scrutiny, and even gives you the option to submit this new fingerprint. By doing this, you're not just enhancing your network security, you're actively contributing to a smarter, more robust device identification system. Each new combination helps build a more comprehensive database, making future identifications quicker and more accurate. It's a continuous cycle of learning and adaptation, ensuring your network stays secure and informed. A finger bank combination is essentially a unique fingerprint for devices in a network. It's made up of several key attributes. First, we have the DHCP option set, which helps identify how a device communicates over the network. Then there's the MAC address OUI, which reveals vendor ID. Think of it as the brand label of the device. Next up is the HTTP user agent string, providing insight into the browser and operating system in use. Finally, we have the TLS client hello details, which come into play if encryption is enabled. When these attributes don't align with anything in the fingerbank database, PacketFence flags it as a new combination, allowing for better network security and management. It's a fascinating way to keep our network safe and organized. Understanding the importance of new devices and OS versions is crucial in today's tech landscape. Each time a smartphone or IoT device hits the market, it brings unique identifiers that can enhance our ability to recognize and manage network traffic. This is where Fingerbank comes in. By submitting new combinations of devices, we contribute to a global database that improves identification accuracy. But it's not just about the latest gadgets. Custom devices and spoofing present challenges that require our attention. A manually configured DHCP client or a spoofed device can disrupt network integrity. By recognizing these anomalies, we can better secure our networks and ensure that only legitimate devices gain access. Every contribution we make helps build a more robust identification system, making our digital environments safer and more efficient. So, when you encounter a new device or configuration, remember, your input matters. It's all about enhancing our collective understanding and security in this ever-evolving tech world. When a new combination is detected in PacketFence, the system kicks into action. First, it logs the event, capturing every detail in pf.log or the web admin console. You can easily track what's happening. Next, this new combination appears in the node details under device fingerprint, giving you a clear view of what devices are on your network. Initially, it's tagged as unknown or unclassified, which means it's time to take a closer look. You have options here. You can manually submit that fingerprint to fingerbank.org, helping to expand the database and improve detection for everyone. Alternatively, you can assign a local override, classifying it based on your own insights. For those looking to enhance security, you can even trigger specific policies based on these unknown fingerprints. This proactive approach not only keeps your network secure, but also helps you stay one step ahead of potential threats. When a new combination is detected in PacketFence, the system kicks into action. First, it logs the event, capturing every detail in pf.log or the web admin console. You can easily track what's happening. When you encounter a new device that needs a fingerprint, the first step is to log into your Fingerbank account. If you don't have one yet, creating it is quick and easy. Head over to fingerbank.org and get started. Once you're logged in, you'll want to submit necessary information. This includes the DHCP fingerprint, which is crucial for identification. If you have the user agent string available, include that too. It adds another layer of accuracy. You can also provide the MAC OUI, but that's optional. After you submit, the Fingerbank team will review your combination. Once approved, the database gets updated, ensuring that future devices are classified correctly. It's a simple process that helps everyone in the community. So, let's keep the database robust and accurate. Managing devices in PacketFence. It's crucial to keep an eye on new combinations. Navigate to Nodes and select List Nodes. If you spot a node with an unknown fingerprint, dive into the Device Details section. Here, you'll find valuable information like the DHCP fingerprint and user agent. Pay attention to any device types marked as unknown. This could indicate a device that needs classification. For those using a local Fingerbank database, you have the power to create overrides. Head to Configuration, then Fingerbank, and select Local Overrides. Here, you can add a new entry with the specific fingerprint details and assign a device type. This is especially handy when you're offline or dealing with proprietary equipment that doesn't fit standard classifications. Taking these steps ensures your network remains organized and secure. When managing devices in PacketFence, it's crucial to keep an eye on new combinations. Navigate to Nodes and select List Nodes. Imagine a world where every device is uniquely identified, not just by its IP address, but by a rich tapestry of fingerprinting attributes. That's the essence of the new Fingerbank combination. When devices connect through PacketFence during onboarding, they reveal previously unseen characteristics that enhance our understanding of them. This isn't just about identification, it's about security and efficiency. Each unique fingerprint is logged and can even trigger alerts or policies, ensuring that anomalies are detected in real time. The purpose? To refine device profiling and bolster our defenses against potential threats. With this innovative approach, we're not just keeping pace with technology, we're staying one step ahead. Imagine a world where every device is uniquely identified, not just by its IP address, but by a rich tapestry of fingerprinting attributes. That's the essence of the new Fingerbank combination. In PacketFence, DHCP fingerprints and DHCP vendors play a role in identifying devices on our network. When a device requests an IP address, it sends specific information that reveals its identity. This data includes the DHCP fingerprint with digital signature, unique to each device. By analyzing this fingerprint, PacketFence can classify devices, whether it's a smartphone, a printer, or a smart TV. But it doesn't stop there. The DHCP version adds another layer of detail, providing insights into the manufacturer. This means we can not only see what type of device is connecting, but also who made it. This classification helps us enforce security policies tailored to each device type, ensuring that our network remains safe and efficient. Understanding these elements is key to managing network access effectively and keeping potential threats at bay. A DHCP fingerprint is like a unique signature for devices when they request a DHCP. Each device has a specific pattern of DHCP option, like option 55, which tells the server what it needs. This is crucial for identifying the type of device, whether it's an iPhone, a Windows 10 PC, or an Android tablet. When a device connects to the network, PacketFence springs into action. It checks the DHCP request and compares the sequence of options against its fingerprint database. Finds a match. It can pinpoint the operating system or device type with impressive accuracy. For instance, a Windows 10 PC might request options in a splitter 1, 15, 3, 6, 44, 46, 47, 31, 33, 121, 49, 43. This sequence acts as its fingerprint, allowing PacketFence to label the device correctly. It's a smart way to enhance network security and manage devices efficiently. A DHCP fingerprint is like a unique signature for devices when they request a DHCP lease. Each device sends a specific pattern of DHCP options, like option 55, which tells the server what it needs. This is crucial for identifying the type of device. It's an iPhone, a Windows 10 PC, or an Android tablet. When we talk about DHCP vendors in PacketFence, we're diving into the intricacies of network identification. The vendor class identifier, or option 60, plays a crucial role here. It's like a digital fingerprint for DHCP clients, helping to clarify who's who in a crowded network. Imagine a device broadcasting option 60 with MSFT 5.0. That's a clear signal that it's a Microsoft DHCP client. This additional layer of identification is invaluable, especially when DHCP fingerprints might lead to confusion. PacketFence takes this information and maps it to known vendors, ensuring that network administrators can manage devices with precision. This not only enhances security, but also streamlines network management, making it easier to keep track of all the devices connecting to your network. Understanding these nuances can significantly improve how we handle network traffic and device identification. In PacketFence, fingerprints and vendor information play a crucial role in device profiling. This means we can easily identify what type of device is connecting to our network. Imagine a gaming console trying to join. We can automatically enforce policies that place it in a different VLAN, keeping our network organized and secure. But it doesn't stop there. These tools also enhance our security measures by alerting us to rogue devices or any unrecognized patterns that could signal a potential threat. You can dive into these features in the PacketFence admin UI under configuration. Just head to fingerprints and DHCP vendors to view or edit the details. It's all about creating a smarter, safer network environment. To configure DHCP fingerprints and vendors in PacketFence, start by accessing the admin interface at your PacketFence IP. Once logged in, navigate to Configuration, then Fingerprinting, and select Fingerprints. Here, you can view existing DHCP fingerprints. To add a new one, click Add, choose DHCP as the type, and enter the option list from the DHCP request, like 1, 3, 6, 15, 31, 33, 43, 44, 46, 47. Specify the OS, such as Windows 10 or Android, and optionally categorize it. Don't forget to save your changes. Next, head to the DHCP vendor section under fingerprinting. Click Add to input the vendor class identifier, like MSFT 5.0, and a readable vendor name, such as Microsoft. Ensure it's enabled and save. After these changes, go to Status and reload FingerBank, or restart the PFDHCP service via the command line. Finally, connect a test device to your network and check the active nodes section to verify that the OS and vendor are detected correctly. Remember, PacketFence leverages the FingerBank project for community-shared fingerprints, so you can even submit new ones directly from the interface. PacketFence, understanding MAC vendors is crucial for network management. Each device has a unique MAC address, and the first 3 bytes, known as the Organizationally Unique Identifier, or OUI, reveal the manufacturer. This insight allows us to find devices on our network quickly.
Imagine a scenario where a new device connects. By checking its MAC prefix, we can determine if it's a trusted brand or something suspicious. This capability empowers us to create tailored policies, ensuring that only authorized devices access sensitive areas of our network. Plus, monitoring device behavior becomes a breeze when we know who made it.
By leveraging MAC vendor information, we enhance security and streamline our network management, our jobs easier, and our networks safer. PacketFence has a powerful feature that automatically detects MAC vendors using the first 3 bytes of a device's known as the Organizationally Unique Identifier, or OUI. This is a game changer for network management. By identifying the manufacturer of a device, we can classify devices more effectively and apply tailored security policies. MAC vendor file, which PacketFence relies on, is based on the IEEE OUI list. This means it's always up to date, as PacketFence can download and refresh this list regularly. Imagine the efficiency. No more guessing about what devices are connecting to your network. With this automatic MAC vendor lookup, you gain insights that enhance security and streamline device management, making your network not just smarter, but also safer. PacketFence has a powerful feature that automatically detects MAC vendors using the first 3 bytes of a device's MAC address, known as the Organizationally Unique Identifier, or OUI. This is a game changer for network management. Updating MAC vendors is crucial for maintaining an efficient network. You can easily refresh the vendor list using a built-in script with a simple command: bash copy edit, usr local pf bin pf update twi. If you prefer a more hands-on approach, you can manually download the latest OUI list from IEEE standards. Once updated, you can view the vendor information in the PacketFence admin portal. Just navigate to the Nodes or Devices section, and you'll see the vendor associated with each MAC address. This is where it gets interesting. Using vendor information in your network access policies allows you to create tailored rules. For instance, you can set up a policy that automatically grants Apple devices access to a specific VLAN. This not only streamlines your network management, but also enhances security and user experience.
Keeping your vendor list current is a game changer.
In PacketFence, user agents play a crucial role in managing network security and access control. These software agents interact with devices and users, gathering vital information about their status and compliance with security policies. For instance, when a device connects to the network, the user agent assesses its security posture, checking for antivirus updates or system patches. If the device doesn't meet the criteria, the user agent can enforce policies, restricting access until compliance is achieved. Additionally, user agents facilitate seamless onboarding for new devices, ensuring they're registered and authenticated before gaining full network access. They also help in monitoring user behavior, allowing for real-time responses to potential threats. By leveraging user agents, PacketFence creates a dynamic environment where security and accessibility go hand in hand, ensuring a safer network for everyone. Devices connect to it and hit the PacketFence captive portal. They send a user agent string that reveals a treasure trove of info. This string tells us about the operating system, the browser type and version, and either the device is a mobile or desktop. It's like a digital fingerprint. With this data, PacketFence can perform device fingerprinting, allowing for more tailored network policies. Imagine a scenario where your device is recognized instantly, and the right access policies are applied without you lifting a finger. It streamlines logging and troubleshooting, making network smoother than ever. By parsing these user agent strings, we can enhance security, user experience, and ensure that every device connects seamlessly. It's all making the network smarter and more responsive to the needs of its users. PacketFence agents, or probes, play a crucial role in network management by acting as user agents that gather vital data and enforce security rules. Think of them as the diligent workers behind the scenes. For instance, an Active Directory agent authenticates users, ensuring that only the right people gain access to sensitive resources. Meanwhile, SNMP user agents tirelessly discover devices on the network, mapping out every connected endpoint. These agents communicate seamlessly, collecting information on device health and compliance, which helps maintain a secure environment. By leveraging these background services, organizations automate processes, enhance visibility, and respond swiftly to potential threats. In essence, PacketFence agents are the unsung heroes of network security, working tirelessly to keep our systems safe and efficient. PacketFence agents, or probes, play a crucial role in network management by acting as user agents that gather vital data and enforce security rules. Think of them as the diligent workers behind the scenes. In the world of network control, user agents play a crucial role in maintaining security. They identify who the user is, what they're connecting with, and whether the device meets compliance standards. Imagine this. You're trying to access a network and the system checks your credentials and device status. If everything checks out, you gain access seamlessly. But if there's a compliance issue, PacketFence steps in. It can redirect you to a remediation portal, guiding you through the necessary steps to fix the problem. And if your device doesn't meet the standards, access is blocked, protecting the entire network from potential threats. This intelligent system ensures that only authorized, compliant devices can connect, keeping our digital environment secure and efficient. This intelligent system ensures that only authorized, compliant devices can connect, keeping our digital environment secure and efficient. In the world of network access control, user agents play a crucial role in maintaining security. They identify who the user is, what device they're connecting with, and whether that device meets compliance standards. PacketFence is a powerful open-source network access control system that truly transforms how we manage network security. Imagine having a tool that not only controls access, but also detects anomalies in real time. With its robust integration capabilities, PacketFence works seamlessly with various network components, ensuring that every device is monitored and managed effectively. What sets it apart is its combination of techniques for anomaly detection. It analyzes network behavior, identifies unusual patterns, and alerts you before potential threats escalate. This proactive approach is crucial for incident response, allowing organizations to act swiftly and mitigate risks. In a world where network security is paramount, PacketFence stands out as a comprehensive solution, empowering you to maintain a secure and efficient network environment. It's not just about access control, it's about safeguarding your entire network land. Anomaly detection is crucial in today's cybersecurity landscape, and PacketFence excels in this area. By integrating with powerful intrusion detection systems like Snort and Suricata, PacketFence can effectively monitor traffic for known attack patterns and unusual behaviors. Imagine a digital watchdog tirelessly inspecting every packet that flows through your network. When an anomaly is detected, Fence springs into action, automatically quarantining the suspicious device to prevent potential breaches. This proactive approach not only helps in mitigating threats, but also ensures that your network remains secure and resilient. With PacketFence, you're not just reacting to threats, you're staying one step ahead in the ever-evolving world of cybersecurity. Network anomaly detection is crucial in today's cybersecurity landscape, and PacketFence excels in this area. World of network security, understanding behavior is key. Imagine a sudden traffic spike. It's like a crowded highway during rush hour. PacketFence is on it, analyzing every packet to ensure nothing suspicious is happening. Then there's unusual port usage. It's like someone trying to sneak in through a back door. We catch that too. MAC address spoofing. That's when someone tries to disguise their identity. But with PacketFence, we see right through the disguise. And let's not forget DHCP fingerprint mismatches. These are like missed fingerprints at a crime scene, signaling something. Unauthorized VLAN access is another red flag. It's like someone private party uninvited. When any of these behaviors deviate from the norm, PacketFence doesn't just sit back. It triggers alerts and initiates rule-based responses, ensuring your network is secure and resilient. It's all about keeping the digital landscape safe and sound. In the world of network security, understanding behavior is key. Imagine a sudden traffic spike. It's like a crowded highway during work. Radius accounting is a full tool that goes beyond just tracker activity. It collects detailed data and relates it with user identities, devices, and network zones. Imagine this. Every time someone logs in, Radius is there, analyzing the context. If a user suddenly tries to access the network from a different country or an unfamiliar device, that's a red flag. This correlation helps us detect anomalies in real time, allowing us to respond swiftly to potential security threats. By understanding the relationships between users and their environments, we can enhance our security posture and protect sensitive information. It's not just about monitoring, it's about creating a smart network. Radius accounting is a powerful tool that beyond just tracking user activity. It collects detailed data and correlates it with user identity, devices, and network zones. Integrating Fence with flow analyzers like NetFlow, SFlow, or IPFIX collectors, such as NTOPNG or NProbe, opens up a powerful avenue for flow-based anomaly detection. Imagine having the ability to spot DDoS behavior in real time, identifying those massive traffic spikes that signal an attack before it wreaks havoc. But it doesn't stop there. With this integration, you can also detect scans and sweeps, those probing attempts by malicious actors trying to find vulnerabilities in your network. And let's talk about lateral movement detection. This is crucial. It helps you track unauthorized access within your network, ensuring that once an intruder breaches the perimeter, you can catch them moving around. By leveraging flow data, PacketFence not only enhances your security posture, but also actually keep your network safe and sound. This is the future of proactive network security, and it's right at your fingertips. When it comes to alert and alarm systems, anomalies can trigger a cascade of responses that keep our network secure. Imagine an unexpected spike. This could send SNMP traps to our monitoring systems, alerting us. Administrators receive emails, ensuring no critical event goes unnoticed. But it doesn't stop there. We can initiate automatic isolation through VLAN switches or firewall rules, effectively quarantining potential threats before they escalate. Custom rules and thresholds are game changers. Administrators can define specific parameters for packet inspection, monitoring the number of connection attempts, or tracking the volume of data sent and received. This level of customization allows us to tailor our to the unique needs of our environment, ensuring we stay one step ahead of potential breaches. With these tools at our disposal, we can maintain a robust security posture and respond proactively to any anomalies that arise. In PacketFence, a network behavior policy acts like the guardian of our digital realm. Imagine tools that defines what's acceptable for devices and users on the network. These policies are crafted by administrators who know exactly what to look for. When a device strays from the path, maybe it's acting suspicious or access unauthorized areas, PacketFence springs into action. It can automatically isolate that device, preventing potential threats before they escalate. This proactive approach not only keeps our network secure, but also ensures that everyone knows the boundaries. With clear guidelines in place, we can enjoy a safer, more efficient network environment. It's all about maintaining order in the chaos of connectivity. In PacketFence, a network behavior acts like the guardian of our digital realm.
A network behavior policy in PacketFence is like a security guard for your network, constantly monitoring of every connected. Imagine a lookout for rogue devices that don't belong, or those misbehaving gadgets that could compromise. It ensures compliance by checking if devices have the latest or the right OS version.
When a threat is detected, like an alert from an intrusion detection system, it springs into action, isolating the offending device to protect the rest of the network. Plus, it can limit based on user roles, or even how much using. This dynamic approach keeps the network secure and efficient, adapting to the ever-changing landscape of threats and user behavior. It's all about maintaining a safe and compliant environment for everyone connected. A network behavior policy in PacketFence is like a security guard for your network, constantly monitoring the behavior of every connected device. Imagine it's on the lookout for rogue devices that don't belong, or those misbehaving gadgets could compromise security. Network behavior policy is essential for maintaining security and efficiency in our digital environments. PacketFence plays a crucial role in this by collecting data from various sources. It taps into DHCP and DNS to device connections and their activities.
Radius and 802.1x provide authentication details, ensuring only authorized devices access the network. Then there are IDS IPS alerts from systems like Suricata and Snort, which identify potential threats in real time. PacketFence also leverages NetFlow and SFlow to analyze traffic patterns, giving insights into bandwidth usage and potential anomalies.
SNMP traps contribute to monitoring network devices, while device profiling, through Mac OUI and fingerprinting, enables us to recognize and categorize devices accurately. This comprehensive data collection allows us to enforce policies effectively, ensuring a secure and well-managed network environment. In today's digital landscape, defining policy conditions is crucial for robust network security. Imagine being able to set rules based on MAC addresses or IPs, ensuring only authorized devices connect. You can tailor access by device type or system, blocking outdated or vulnerable tech.
User roles add another layer. Different permissions for admins versus guests keep sensitive data safe. V's and SSIDs help segment traffic, isolating critical systems from potential threats. And let's not forget event types. Monitoring for IDS alerts, port scans, or rogue DHCP servers can proactively defend against attacks.
Plus, tracking connection counts and bandwidth usage helps identify unusual patterns, signaling potential breaches. With these tools, you can create a dynamic security environment that adapts to the ever-evolving threats we face. Once it is flagged for non-compliance, the first step is to change its VLAN, often moving it to a quarantine zone. This isolates the device, preventing any potential threats from spreading. Next, alerts are sent out. Think of it as a digital alarm system via email or SNMP, notifying the team of the issue. Access is then blocked, either through the firewall or by disabling the switch port, ensuring that the compromised device can't connect to the network. Users are redirected to a remediation portal, where they can see what needs fixing, like updating their antivirus software. Once they comply, it happens. The system can automatically route the device to the production VLAN to re-enable access, streamlining the process and keeping our network secure. Seamless flow not only protects our infrastructure, but also enhances user experience by minimizing downtime. When it's flagged for non-compliance, the first step is to change its VLAN, often moving it to a quarantine zone. This isolates the device, preventing any potential threats from spreading. Imagine this. Your network is buzzing with activity and suddenly an IDS alert pops up. Port scan detected. That's a red flag. We need to act fast. First, we move that device to a quarantine VLAN. If it's running Windows XP, it's even more critical. This outdated OS is a prime target for attacks. Next, we've got an unknown device, DHCP flood. Time to send an alert. We can't let rogue compromise our network integrity. But what about remediation? We redirect the user to a remediation portal, guiding them through the necessary steps to secure their device. In this fast-paced digital world, proactive measures are key. Every alert is a chance to tighten our defenses and keep our network safe. Stay vigilant. In PacketFence, the scan engine is like a digital security guard, tirelessly assessing every device that tries to connect to our network. It dives deep, scanning for vulnerabilities and checking if devices comply with our security policies. Imagine it as a meticulous inspector, identifying crucial details like operating systems and open ports. This information is vital. It helps us decide whether a device gets the green light to join the network, needs to be quarantined, or should be outright denied access. By enforcing these access control policies, we ensure our network remains secure and resilient against potential threats. It's all about maintaining a safe digital environment while keeping things running smoothly. In PacketFence, a scan engine is a component used to assess the security posture of devices connecting to a network. It works by scanning endpoints for vulnerabilities, policy compliance, or identifying device characteristics, like OS or open ports. These scans help enforce network access control policies by determining whether a device should be allowed on the network, quarantined, or denied access. Scan engines in PacketFence play a crucial role in enhancing network security. First, they conduct vulnerability assessments, identifying known security flaws on devices, like unpatched software that could be an open door for attackers. Next, they ensure policy compliance by checking for essential elements such as antivirus presence, firewall status, and the operating system version. This helps maintain a secure environment across the board. Finally, device profiling comes into play, classifying devices based on their behavior and characteristics, whether it's a printer, phone, or laptop. This classification not only streamlines management, but also enhances security by allowing tailored policies for different device types. With these functions, scan engines are essential in safeguarding our networks and ensuring compliance. Scan engines in PacketFence play a crucial role in enhancing network security. First, they conduct vulnerability assessments, identifying known security flaws on devices, like unpatched software that could be an open door for attackers. PacketFence is a powerful tool that seamlessly integrates with various scan engines to enhance network security. Imagine leveraging OpenVAS for comprehensive vulnerability assessments, or using Nessus to identify potential threats before they become a problem. Nmap is another gem in our toolkit, perfect for network scanning and OS detection, giving us insights into our environment like never before. Then there are SNMP scans, which help us identify network devices effortlessly, ensuring nothing slips through the cracks. And for those unique situations, custom scripts and external tools can be hooked in, allowing for tailored solutions that meet specific needs. With PacketFence, the possibilities are endless, making it an essential ally in the fight against cyber threats. Imagine this. A device connects to your network, and instantly, PacketFence springs into action. It triggers a scan using powerful tools like Nmap or OpenVAS. Within moments, you get a detailed report. Maybe it flags that the device is missing a critical patch. What happens next? Instead of letting that vulnerability linger, PacketFence automatically places the device into a quarantine VLAN. This means it's isolated from the rest of your network until it meets compliance standards. It's like having a digital bouncer, ensuring only secure devices get access. This proactive approach not only protects your network, but also keeps you one step ahead of potential threats. With PacketFence, you can rest easy knowing your network is safeguarded and compliance is just a scan away. When a device connects to the network, PacketFence can trigger a scan via Nmap or OpenVAS. Based on the results, e.g., device missing a critical patch, it can place the device in a quarantine VLAN until it's compliant. In PacketFence, every In the world of network security, several common events can signal trouble. First up, we have virus or malware detection, often caught by systems like Snort or Suricata. Then there's port scanning, where devices probe for open doors into our network. Watch out for DHCP spoofing, unauthorized servers trying to hijack IP assignments. MAC spoofing is another sneaky tactic, where devices change their MAC address to impersonate others. Policy violations are crucial too. Devices that don't meet compliance checks, like missing antivirus or outdated operating systems, can put the entire network at risk. Rogue device detection helps us identify unregistered or suspicious devices lurking around. And let's not forget about 802.1x authentication failures, which indicate failed attempts to connect via Radius. Finally, network behavior anomalies can reveal abnormal traffic patterns, hinting at misuse or potential intrusions. Staying vigilant against these events is key to maintaining a secure network.
PacketFence is a powerful tool that transforms security events into actionable responses. When a potential threat is detected, it alerts administrators instantly, ensuring they're always in the loop. But it doesn't stop there. If a device poses a risk, PacketFence can quarantine it by moving it to a restricted VLAN, effectively isolating the threat from the network.
Now, what about users? PacketFence takes a proactive approach by redirecting them to a remediation portal, guiding them through the steps to resolve any issues. This not only helps users, but also strengthens the overall security posture. And let's not forget about logging and auditing. Every event is meticulously recorded, providing a comprehensive trail for compliance and investigation. This level of detail is crucial for understanding security incidents and improving defenses. PacketFence truly turns security events into a robust framework for protection and accountability. How PacketFence uses security events: alerting, sends notifications to administrators; quarantine, moves a device to a restricted VLAN; remediation, redirects users to a portal to resolve issues; logging and auditing, records for compliance and investigation. Accessing security events in PacketFence is straightforward and essential for maintaining your network's integrity. First, open your browser and navigate to https://forwarding43. Once logged in with your admin credentials, head over to any threats. In PacketFence, the event logger is like the vigilant guardian of our network. It tirelessly collects and records every significant event, from user logins to security breaches. Imagine having a detailed diary that tracks all the happenings in your environment. This is what the event logger does. It's essential for network monitoring, allowing us to spot anomalies and troubleshoot issues before they escalate. When it comes to auditing, these logs provide a clear trail of actions, ensuring accountability and compliance. Plus, they play a crucial role in security enforcement, helping us respond swiftly to threats. In a world where every second counts, the event logger is our first line of defense, keeping our network safe and sound. In PacketFence, an event logger is a component responsible for collecting and recording various system and network events that occur within the PacketFence environment. These logs help with network monitoring, troubleshooting, auditing, and security enforcement. Event loggers in PacketFence play a crucial include forwarding to external SIEMs like Splunk or the ELK stack. When it comes to event logging in PacketFence, there are several powerful tools at our disposal. First up is Syslog, which handles system-level logging with precision, capturing essential data from various sources. It's like the backbone of our logging strategy, ensuring we don't miss a beat. Then we have PF Logger, a unique Perl-based logger specifically designed for PacketFence. This tool is tailored to our needs, making it easier to track and manage events that are crucial for network security. It's efficient and integrates seamlessly into our existing framework. Lastly, let's talk about ELK integration. This trio of Elasticsearch, Logstash, and Kibana take our logging to the next level, offering advanced visualization and analysis. With ELK, we can sift through vast amounts of data, uncovering insights that help us respond to incidents more effectively. Each of these logging mechanisms plays a vital role, ensuring we maintain a secure and efficient network environment. PacketFence may use different event logging modules or mechanisms such as Syslog for system-level logging, PF.Logger, a PacketFence-specific Perl-based logger, and ELK integration for advanced log visualization and analysis. Firewall SSO in PacketFence is a game changer for user authentication. Imagine a world where you don't have to log in multiple times just to access your network. With this single sign-on mechanism, PacketFence seamlessly integrates with your firewall, allowing it to recognize who you are and your IP address without the hassle of a captive portal. This is especially beneficial in environments where users are already authenticated through services like Active Directory. The firewall shares that session information directly with PacketFence, making the whole process smooth and efficient. No more interruptions, just a streamlined experience that keeps you connected while enhancing security. It's all about making your network access as effortless as possible while still maintaining robust protection. Firewall SSO in PacketFence is a game changer for user authentication. Imagine a world where you don't have to log in multiple times just to access your network.
Firewall SSO in PacketFence is a game changer for network security. Imagine a world where users don't have to repeatedly log in every time they connect. That's exactly what Firewall SSO does.
It allows PacketFence to pull user identity and IP information directly from firewalls like Fortinet, FreeGate, or Palo Alto. When a user logs in, PacketFence monitors or queries the firewall for login events or session data, instantly recognizing who they are. This seamless integration not only enhances experience, but also streamlines network management.
No more frustrating re-authentication. Users stay connected while PacketFence ensures security. It's efficient, it's smart, and it's the future of network access control.
PacketFence is a powerful network access control solution that seamlessly integrates with several leading firewalls. Among the top contenders are Fortinet's FortiGate and Palo Alto networks. These firewalls enhance PacketFence's capabilities, allowing for robust security measures and efficient traffic management. With FortiGate, you get advanced threat protection and deep visibility into your network, while Palo Alto offers unparalleled application awareness and granular control. What's exciting is that PacketFence can also connect with other firewalls through syslog or API-based integration, expanding its versatility. This means you can tailor your security setup to fit your unique needs, leveraging the strengths of various firewalls. Whether you're managing a small business or a large enterprise, integrating PacketFence with these firewalls ensures that your network remains secure, compliant, and efficient. The synergy between these technologies creates a formidable defense against evolving cyber threats. Configuring Firewall SSO in PacketFence is straightforward. First, head to the PacketFence admin UI and navigate to Configuration, then SSO Sources. Click Add, select Firewall, and fill in the details. Name it something like Fortinet SSO. Enable it, choose your firewall type, and set up the syslog listener with the appropriate IP and port, typically port 514. If your firewall requires a secret or password, make sure to include that too. Next, let's configure the firewall itself. For Fortinet FortiGate, enable syslog forwarding to the PacketFence IP and ensure you're logging user login events, especially for VPN or web logins. You might also need to enable the SSO agent or FSSO. If you're using Palo Alto, enable user ID and set up syslog or XML API forwarding. Don't forget to create a syslog profile to forward those crucial user login events to PacketFence. Finally, on the PacketFence side, it's all about parsing and matching the information. PacketFence will take the logs or API calls and map the username to the IP address and MAC address. This allows it to apply the correct role, VLAN, or policy based on that identity. It's efficient and ensures your network security is tight. Fleet DM isn't a built-in part. Fleet DM is an open-source platform that transforms how we manage and monitor our endpoints. Built around Oscary, it empowers security and IT teams to dive deep into their systems using SQLite queries. Imagine having the ability to pull detailed insights on installed software, logged in users, running processes, security configurations, and even hardware details, all from a central server. With Fleet DM, you can effortlessly manage Oscary agents across client machines, ensuring that your organization stays secure and compliant. It's like having a powerful magnifying glass that reveals the hidden intricacies of your endpoints, making your job not just easier but smarter. Whether you're tracking down vulnerabilities or optimizing performance, Fleet DM is your go-to solution for endpoint visibility and management. What is Fleet DM? Fleet DM is an open-source endpoint visibility and management platform built around Oscary. It allows security and IT teams to query and monitor their endpoints using SQLite queries. You can get detailed information about installed software, logged in users, running processes, security configurations, and hardware details. Fleet DM acts as a central server that manages Oscary agents installed on client machines. PacketFence is an open-source network access control system that revolutionizes how we manage network security. Imagine a world where every device connecting to your network is authenticated seamlessly through 802.1x, or a captive portal. That's the power of PacketFence. It not only ensures that only authorized users gain access, but also allows for easy device registration, making BYOD policies a breeze. But it doesn't stop there. With VLAN isolation, you can segment your network to protect sensitive data and maintain performance. Plus, it integrates with powerful intrusion detection systems like Snort and Suricata, keeping your network safe from threats. PacketFence is not just a tool. It's a comprehensive solution that empowers organizations to take control of their network access and security. Embrace the future of network management with PacketFence. What is PacketFence? PacketFence is an open-source network access control (NAC) system. It provides authentication, 802.1x captive portal, device registration, VLAN isolation, intrusion detection, integration, Snort, Suricata, BYOD support. In today's complex network environments, combining Fleet DM and PacketFence can elevate your security posture significantly. Imagine having Fleet DM provide you with detailed insights into every device connected to your network. You can see if antivirus software is installed, whether the operating system is up to date, and assess other critical security metrics. Now integrate that with PacketFence, which can enforce network access control based on these insights. If a device doesn't meet compliance standards, PacketFence can restrict its access, ensuring that only secure, compliant devices can connect. This synergy not only enhances visibility, but also strengthens your overall security framework, making your network a safer place. While FleetDM and PacketFence serve different primary purposes, FleetDM for endpoint visibility and PacketFence for network access control, they can be used together in environments where you want detailed insight into devices connected to the network via FleetDM and control or restrict access based on compliance or posture via PacketFence. For example, PacketFence could query FleetDM or be integrated via API or third-party middleware to check if antivirus is installed, if the OS is up to date, and other security postures. Imagine a scenario where your organization's network is constantly under threat from unauthorized devices. This is where FleetDM and PacketFence come into play. By integrating FleetDM, which provides real-time visibility into all devices on your network, with PacketFence's robust network access control, you create a powerful security duo. Picture this. FleetDM identifies a rogue device trying to connect. Instantly, it sends an alert to PacketFence, which can automatically quarantine that device, preventing it from accessing sensitive data. Meanwhile, FleetDM ensures that all compliant devices are updated and secure, enforcing policies that keep your network safe. This integration not only enhances your security posture, but also streamlines compliance enforcement. You get real-time insights and automated responses, making your network resilient against threats. With FleetDM and PacketFence working together, you can confidently manage your devices and protect your organization from potential breaches. In PacketFence, web services are like the secret sauce that lets external systems and administrators tap into the power of our platform. Imagine a set of RESTful APIs that open the door to seamless interactions. With these services, you can automate tasks like managing devices on your network, enforcing security policies, or even retrieving real-time data on network status. Need to integrate with a third-party application? No problem. The APIs make it easy to pull in information or push updates, ensuring everything works in harmony. Whether you're looking to enhance your network visibility or streamline operations, PacketFence's web services empower you to do it all with precision and efficiency. It's all about making your network management smarter and more responsive. In PacketFence, a web service refers to a set of APIs and interfaces that allow external systems or administrators to interact with the PacketFence system programmatically. These services are typically RESTful APIs and are used for tasks such as In the world of PacketFence, web services are game changers. Imagine registering or managing your network device from anywhere. It's as simple as a few clicks. Node management takes it a step further. You can effortlessly add, update, or delete nodes identified by their MAC addresses, keeping your network organized and secure. User management is equally powerful. You can create and manage user accounts for captive portals or 802.1x authentication, ensuring that only authorized users gain access. And let's not forget VLAN assignments. Interacting with VLANs based on device or user policies allows for dynamic network segmentation, enhancing security and performance. Finally, the integration with external systems is where the magic happens. Syncing PacketFence with SIEMs, identity providers, or custom portals means you can streamline operations and enhance your security posture. With these web services, managing your network has never been more efficient or effective. Common uses of web services in PacketFence. Device registration. Register or manage network devices in PacketFence remotely. Node management. Add, update, or delete nodes. Devices identified by MAC addresses. User management. Create or manage user accounts, e.g. for CAP portal or 802.x authentication. VLAN assignment. Interact with VLAN assignments based on device.user policy decisions. Integration with external systems. Sync or connect PacketFence with other systems like SIEMs, identity providers, or custom portals. In PacketFence, things like SNMP versions, CLI login commands, and port control methods across multiple devices. Switch templates are a game changer. First off, they bring standardization to the table, eliminating the tedious task of manually configuring each switch with repetitive settings. Imagine the time saved. Then there's efficiency. Onboarding new switches becomes a breeze. Just apply the template and you're good to go. Central management is another huge benefit. With templates, managing large-scale networks becomes consistent and effective, allowing for seamless updates and configurations across the board. Plus, they support multiple vendors, which means you can tailor templates for specific switch types. This flexibility ensures that no matter the hardware, you're always ready to roll. Embracing switch templates not only simplifies your workflow, but also enhances the overall performance of your network. In configuring a switch, the first step is to access the CLI using the right credentials. Depending on vendor and model, you might use Telnet or SSH for secure access. SSH is preferred for its encryption, keeping your data safe. Once logged in, SNMP settings come into play. You'll want to set the SNMP version, typically v2c or v3, and configure your community strings for monitoring. Next, let's talk VLANs. Use commands like VLAN ID to create and assign VLANs, ensuring your network traffic is segmented efficiently. For security, MAC address control is crucial. Implement port security with commands like switch port security to limit the number of MAC addresses per port. Port isolation can further enhance security by preventing devices on the same VLAN from communicating. Finally, if a port needs to be shut down, use shutdown, and to re-enable it, simply type no shutdown. These commands are essential for managing your network effectively. Each step is vital for a robust and secure network environment. When you add a switch fence, you unlock a powerful toolset through switch templates. Imagine having the ability to control and monitor your network effortlessly. With just a few commands, you can bounce a port, shutting it down and bringing it back online in seconds. Need to assign a port to a specific VLAN? It's as simple as click. PacketFence also keeps your network secure by detecting rogue devices, ensuring that only authorized users are connected. And if a device doesn't comply with your policies, you can trigger isolation instantly, protecting your network from potential threats. This level of control and security transforms how we manage our networks, making them smarter and safer. When a switch is added to PacketFence, you can associate it with a switch template. PacketFence then uses the commands and protocols defined in that template to control and monitor the switch. Tasks such as bouncing, shutting down and re-enabling a port, assigning a port to a specific VLAN, detecting rogue devices, and triggering isolation for non-compliant devices. This comprehensive approach ensures that your network remains efficient and secure, adapting to the needs of your organization. To your PacketFence admin interface is straightforward. Just enter https://443 and log in with your admin credentials. Once you're in, head over to the Switch Template section by clicking on Configuration, then Switch Templates. Ready to create a new template? Click Add in the top right corner. Now fill in the field. For the name, choose something descriptive like Cisco 2960 SSH SNMPv2. The description is optional, but it's a great place to add details about your template. Select your vendor, for instance, Cisco, and if you want, specify the model. Next, choose your CLI protocol, SSH, Telnet, or none, and select the SNMP version, whether it's V1, V2C, or V3. The command set is crucial. It dictates how ports are managed, so pick wisely, like Cisco CLI or HP CLI. You can also set specific commands or stick with defaults. Think about the shutdown command for disabling ports, the enable command for re-enabling them, and the VLAN assignment command for moving ports to a VLAN. If you're uncertain, don't worry. PacketFence usually provides sensible defaults based on your vendor. Finally, don't forget to click Save to keep your new template. And just like that, you're all set. Navigating to the configuration is straightforward. First, head over to Configuration and select Switches. If you're adding a new switch, click Add. Otherwise, hit Edit next to the existing one you want to modify. Now, let's fill in those switch details. Give it a unique name. This is your chance to get creative. Next, input the IP address of the switch. For the management protocol, choose between CLI or SNMP, depending on what you're using. Here's the key part. Select the template you just created. This ensures everything is aligned perfectly. Don't forget to add your credentials. Make sure they match the ones configured on the actual switch for seamless access. Finally, save your configuration and you're all set. Go to Switch Configuration. Navigate to Configuration. Switches. Click Add to register a new switch, or click Edit next to an existing switch. Fill in name, a unique name, IP address of the switch, management protocol, e.g., CLI, SNMP, template. Select the template you just created. Make sure the CLI and SNMP credentials match those configured on the actual switch. Save the configuration. Testing the connection is crucial for ensuring PacketFence can effectively communicate with your switch. First, double-check that your SNMP and SSH access are allowed through any firewalls. This step is vital. Without it, you might find yourself in a communication dead zone. Once that's confirmed, dive into the bump port feature under the node details. This tool is your best friend for validating port control. It allows you to quickly check if the port is responding as expected. Remember, a smooth connection means a smoother operation overall. So, take a moment to verify these settings. It'll save you headaches down the line. Trust me, a little diligence now pays off big later. Test the connection to ensure PacketFence can communicate with the switch. Use the bump port feature under the node details to validate port control. Make sure SNMP and/or SSH access is allowed through firewalls to the switch from PacketFence. Event handlers in PacketFence are like the system's vigilant sentinels, always on the lookout for specific events that demand a response. Imagine a switch or a wireless controller sending a signal, or a radius authentication attempt knocking at the door. Each of these events triggers a unique script or process, allowing PacketFence to react swiftly and effectively. When a DHCP request comes in, an event handler can automatically assign an IP address, ensuring seamless connectivity. SNMP traps? They alert us potential issues before they escalate. And let's not forget about intrusion detection systems. Event handlers can initiate defensive measures the moment a threat is detected. Even internal components of PacketFence rely on these handlers to maintain smooth operations. They're the unsung heroes, orchestrating responses that keep our networks secure and efficient. In essence, event handlers are the heartbeat of PacketFence, ensuring that every event is met with the right action at the right time. What are event handlers? Event handlers in PacketFence are scripts or processes triggered when certain events occur in the system. These events can originate from various sources like switches or wireless controllers, radius authentication attempts, DHCP requests, SNMP traps, intrusion detection systems, IDS, and internal PacketFence components. In PacketFence, event handlers are like the vigilant sentinels of your network. Imagine a scenario where a device tries to connect without proper credentials. With event handlers, the system springs into action, automatically isolating that device or sending alerts to the admin. It's all about automation, no manual intervention needed. You set the rules, and when those conditions are met, the event handlers execute predefined actions seamlessly. This not only enhances security, but also streamlines network management. Think of them as the unsung heroes, tirelessly working behind the scenes to ensure your network remains secure and efficient. With PacketFence, you're not just reacting to events, you're proactively managing your network environment. In PacketFence, an open-source network access control (NAC) solution, event handlers are a key component used to automate responses to network events. They allow the system to take specific actions when predefined conditions are met. In PacketFence, event handlers are like the vigilant sentinels of your network. Event handlers are the unsung heroes of automation, responding to events with precision and speed. Imagine a new device connecting to your network. An event handler springs into action, placing it in the right VLAN, ensuring it's where it needs to be. If a rogue device tries to sneak in, these handlers can ban or unban it in an instant, maintaining security without missing a beat. They don't stop there. Assign roles or policies? That's a breeze for them. They ensure every device has the right level of access, keeping your network organized and secure. And when something goes awry, event handlers trigger alerts, logging activity to keep you informed. If a device shows signs of trouble, they can even quarantine it for remediation, isolating the threat before it spreads. In a world where every second counts, event handlers are the automated guardians, reacting swiftly to keep everything running smoothly. What do event handlers do? They react to events by taking automated actions, such as placing a device in a specific VLAN, registering a new device, banning or unbanning a device, assigning a role or policy, triggering alerts or logging activity, and quarantining a device for remediation. Event handlers are the unsung heroes of automation, responding to events with precision and speed. Imagine a new device connecting to your network. An event handler springs into action, placing it in the right VLAN, ensuring it's where it needs to be. If a rogue device tries to sneak in, these handlers can ban or unban it in an instant, maintaining security without missing a beat. They don't stop there. Assigning roles or policies? That's a breeze for them. They ensure every device has the right level of access, keeping your network organized and secure. Syslog forwarding in PacketFence is a powerful feature that enhances your network security posture. Imagine having all your log messages, alerts, events, and system logs streamlined to an external Syslog server. This process not only centralizes your logging, but also makes monitoring a breeze. By integrating with security information and event management systems, you gain real-time insights into your network's health and security threats. It's like having a vigilant watchdog that never sleeps, ensuring that every critical event is captured and analyzed. With PacketFence, you're not just managing logs, you're transforming them into actionable intelligence that strengthens your defenses. Centralized logging has never been this efficient. Centralizing logs is essential for effective analysis, security auditing, compliance, and troubleshooting. By using protocols like UDP or TCP on port 514, we can seamlessly forward logs from various sources. Imagine targeting other Linux servers running Syslog NG or RSYslog, or even powerful SIEM tools like Splunk, Graylog, or the ELK stack. The beauty of this setup lies in its configurability. You can choose exactly which logs to forward, be it authentication events, DHCP logs, radius, or even policy violations. This tailored approach not only enhances security, but also streamlines the troubleshooting process, making it easier to pinpoint issues before they escalate. Centralized logging transforms chaos into clarity, empowering us to maintain robust systems. Centralizing logs is essential for effective analysis, security auditing, compliance, and troubleshooting. By using protocols like UDP or TCP on port 514, we can seamlessly forward logs from various sources. When using PacketFence for network access control, monitoring potential threats and policy violations is crucial. To enhance your security posture, forwarding logs to a SIEM is a game changer. Start by editing the PacketFence Syslog configuration. Navigate to the configuration file, typically found in the PacketFence directory. Here, you'll specify your SIEM server's IP address and the port it listens on. Make sure to set the appropriate log level to capture all relevant events. Once configured, restart the PacketFence service to apply the changes. Now, your logs will flow seamlessly to the SIEM, enabling real-time alerting and historical analysis. This integration not only boosts your threat detection capabilities, but also helps in compliance audits. Stay proactive and keep your network secure. PacketFence has integrated ORX, the Wireless Roaming Intermediary exchange, a game changer developed by the Wireless Broadband Alliance. Imagine effortlessly connecting to Wi-Fi networks as you move between different operators, all without the hassle of logging in repeatedly. With RIX, PacketFence enables seamless roaming, ensuring that your connection remains stable and secure, no matter where you are. This means you can enjoy uninterrupted access to your favorite online services, whether you're at a cafe, in a park, or traveling across cities. The beauty of this integration lies in its ability to enhance user experience while simplifying network management for operators. It's a win-win for everyone involved, making Wi-Fi roaming smoother and more efficient than ever before. In PacketFence, REX, Wireless Roaming Intermediary Exchange, is a framework developed by the Wireless Broadband Alliance, WBA, to facilitate Wi-Fi roaming between operators. PacketFence integrates RICs to support seamless roaming for end users across different networks. Configuring RICs in Packet operation. When diving into the world of RIC standards and guidelines, it's essential to explore the key documents that shape our understanding. The Wi-Fi Roaming Standard, RIC's umbrella document, is a must-read. It lays the groundwork for how we can seamlessly connect across networks. Then there's RICS, Location, or RICL, which delves into the specifics of location-based services within the RICS framework. These documents are treasure troves of insights, offering best practices for service providers and crucial guidelines for effective information exchange. By familiarizing ourselves with these resources, we empower ourselves to enhance connectivity and improve user experiences in the ever-evolving landscape of Wi-Fi roaming. For detailed information on WRIC standards and guidelines, refer to the following WBA documents: Wi-Fi Roaming Standard, RICS Umbrella Document, and RICS Location, RICS-L. These documents provide comprehensive insights into the RICS framework, including best practices for service providers and guidelines for exchanging relevant information between involved parties. In PacketFence, PKI, or public key infrastructure, plays a crucial role in securing our digital communications. Imagine a world where every device on your network can confidently authenticate itself, thanks to digital certificates and public key encryption. PKI ensures that only authorized devices gain access, creating a fortress around your network. It's like having a VIP pass for your devices, allowing them to communicate securely while enforcing strict security policies. In environments that utilize 802.1x network access control, PKI is the unsung hero, managing identities and safeguarding data from prying eyes. With PKI, we're not just protecting information, we're building trust in every connection. In PacketFence, PKI stands for Public Key Infrastructure. It is used to manage digital certificates and public key encryption, ensuring secure communication, device authentication, and enforcement of security policies, particularly in 802.1x network access control environments. In the world of network security, PacketFence's PKI module stands out as a powerhouse. It's all about issuing digital certificates to users and devices, ensuring that every connection is secure. With EAP-TLS, we authenticate endpoints using a robust certificate-based protocol, making unauthorized access a thing of the past. Managing certificate authorities is seamless, whether you're using internal CAs or integrating with external ones. And let's not forget automation. Automating certificate issuance and renewal means secure access is always just a click away. Plus, trusted device onboard is a breeze through portals or identity providers, making it easier than ever to keep your network safe. With PacketFence's PKI, security and efficiency go hand in hand. PacketFence's PKI module is mainly used to issue digital certificates to users or devices, authenticate endpoints using EAP-TLS, a certificate-based authentication protocol, manage certificate authorities, CAs, internally or through integration with external ones, automate certificate issuance and renewal for secure access, and enable trusted device onboarding via portals or identity providers. In PacketFence, the PKI features are game changers for network security. First, it can function as its own internal certificate authority, automatically signing and issuing certificates during device onboarding. This means seamless integration for new devices. With EAP-less authentication, we elevate security by using certificates for 802.1x authentication, ensuring only trusted devices connect. The certificate provisioning portal allows users to request and download certificates effortlessly, perfect for BYOD environments. Plus, with SCEP and EST support, automated certificate enrollment becomes a breeze, integrating smoothly with MDM systems like Microsoft Intune. Managing revoked certificates is straightforward with CRLs and OCSP, ensuring compromised devices are swiftly denied access. MAC address binding adds another layer of security, certificates to specific devices preventing misuse. The integration with Radius and LDAP streamlines authentic policy enforcement, while expiration and renewal policy keep everything up to date. With these features, PacketFence's PKI system is not just secure, it's smart and efficient. Here are the major components and sub-features of PKI in PacketFence. PacketFence can act as its own internal CA. Automatically signs and issues certificates for devices during registration or onboarding. You can also configure it to use external CA, like Microsoft CA. Allows certificate-based 802.1x authentication, more secure than password-based methods. Devices use client certificates to authenticate against the Radius server. Certificates are checked against the trusted CA store in PacketFence. End users or devices can request and download certificates via a self-service portal, useful for BYOD environments. Optionally uses SCF or EST. Allows integration with mobile device management systems and devices like iOS, macOS. Enables automated certificate enrollment over secure channels. Compatible with services like Microsoft Intune or JAMA. Revoked certificates can be managed via CRLs or OCSP. Ensures access is revoked if a device is compromised or offboarded. Certificates can be bound to MAC addresses. enforcing stricter control by tying certificates to physical devices. Prevent certificate sharing or misuse. The PKI system is tightly integrated with PacketFence's Radius server for authentication, can map certificate subjects to LDAP identities for policy enforcement. PKI and PacketFence support certificate expiration tracking and renewal notifications. Policies can define how long certificates are valid and when they must be renewed. PacketFence PKI is a game changer for network security, especially when it comes to 802.1x certificate-based access. Imagine seamlessly connecting devices, both wired and wireless, while ensuring that only authorized users gain entry. With certificate-based authentication, we elevate security, making it nearly impossible for unauthorized access. Now consider guest and BYOD onboarding. Instead of cumbersome processes, PacketFence automates certificate issuance, allowing guests to connect securely without compromising the network. This means a smooth experience for users and peace of mind for administrators. And let's not forget device trust in MDM and EMM systems. By leveraging certificates, we can establish a robust trust framework, ensuring that only compliant devices interact with sensitive data. In a world increasingly leaning towards zero-trust architectures, PacketFence PKI stands as a pillar of security, verifying every device and user, creating a fortress around your network. This is the future of secure connectivity, where trust is earned, not assumed. World of network security, ensuring that only authorized users gain access is crucial. That's where PacketFence comes in. It's not just a network access control solution, it's a robust guardian of your digital environment. By integrating multi-factor authentication, or MFA, PacketFence adds an extra layer of security that goes beyond just a username and password. Imagine trying to access your network and being prompted for a second verification step, maybe a code sent to your phone or a biometric scan. This means even if someone has your password, they still can't get in without that second factor. It's like having a double lock on your front door. With PacketFence, you're not just protecting data. You're ensuring that every device connecting to your network is verified and secure. This proactive approach to access control not only enhances security, but also builds trust in your network's integrity. In the world of network security, ensuring that only authorized users gain access is crucial. That's where PacketFence comes in. When a user tries to access the network, PacketFence kicks off an authentication process. It starts with verifying credentials. Think username and password. But here's where it gets interesting. Once that's done, PacketFence integrates with multi-factor authentication providers like Google Authenticator or Duo Security. This means the user is prompted for a second factor. It could be a code from an authentication app, a push notification to their mobile device, or even a biometric scan, depending on setup. After both factors are verified, PacketFence makes a call, granting or denying access based on the administrator's policies. This layered approach ensures that only authorized users can connect, keeping the network secure and robust. Configuring MFA in PacketFence is a game changer for security. First, you need to choose your MFA provider, Duo, Okta, or another supported service. Once you've selected one, integrate it into PacketFence through the authentication settings. This step is crucial. It's where the magic happens. Next, define your policies to enforce MFA for specific users or groups. This ensures that only authorized individuals can access sensitive areas, adding that vital extra layer of protection. In today's world, where cyber threats are rampant, implementing MFA is not just a good practice. It's essential. It transforms your security posture, making it much harder for unauthorized users to gain access. To configure MFA in PacketFence, you typically need to set up an MFA provider, e.g. Duo, Okta, or another supported service. Integrate this provider with PacketFence through its authentication settings, and define the policies to enforce MFA for certain users or groups. This adds an extra layer of protection beyond simple username password authentication, especially critical in environments where security is a high priority. Configuring MFA in PacketFence is a game changer for security. First, you need to choose your MFA provider, Duo, Okta, or another supported service. When you connect to a network using PacketFence, you encounter a captive portal. Think of it as a digital gatekeeper. This web-based interface pops up, prompting you to authenticate before you can dive into the online world. It's not just a formality, it's a crucial part of network access control. By requiring users to log in, PacketFence ensures that only authorized individuals can access the network, enhancing security and protecting sensitive data. This process also allows organizations to enforce policies like bandwidth limits or usage guidelines. So, the next time you see that login page, remember, it's not just a hurdle, it's a vital shield keeping the network safe and sound. In PacketFence, a captive portal is a web-based authentication interface that is presented to users when they try to access the network. It's one of the core components used for network access control. When you connect to a using PacketFence, you encounter a captive portal. Think of it as a digital gatekeeper. When you connect to a network, the first thing that is your traffic gets intercepted. Suddenly, your HTTP or HTTPS request is directed to a captive portal. This is where the magic, or maybe the frustration, begins. You're greeted with a login page or an acceptable use policy. Here, you might need to enter your credentials, register your device, or simply accept terms of use. Once you've done that, the system makes an access control decision. If everything checks out, you're granted access and placed in a specific VLAN or access role, allowing you to serve freely. But if something's off, find yourself denied access or redirected for further action. It's a crucial step in ensuring network security while keeping users informed and compliant. When a device connects to the network, traffic is intercepted. The user's HTTPS request is redirected to a captive portal. The captive portal displays a logged or an acceptable use policy, AUP. Users may be required to enter credentials, register their device, or accept terms of use. Based on the user's input and policy in PacketFence, is either granted and the user is placed in a VLAN or access role, or denied or redirected for further action. PacketFence's captive portal changer for network access. Imagine having fully customizable registration pages that reflect your brand's identity. You can tailor the user experience to match your style. Plus, it supports multiple authentication sources: DAP, Radius, SAML, and even social media logins. This flexibility means users can connect in the way that suits them best. But that's not all. It seamlessly integrates with guest management systems, making it easy to handle visitor access without a hitch. Device registration and profiling ensure that every device is recognized and managed effectively, and user experience. And the cherry on top? After a successful login, users are redirected back to the site they originally wanted to visit, making the whole process smooth and hassle-free. PacketFence truly elevates network access management. Key features in PacketFence's captive portal: customizable login and registration pages, multiple authentications, LDAP, Radius, SAML, social media, etc. Integration with guest management systems, device registration and profiling, redirection back to the requested site after successful login. In schools and cities, managing student access to Wi-Fi is crucial. Imagine a system that allows students to connect seamlessly, ensuring that only authorized users can access the network. This not only enhances security, also optimizes bandwidth for educational purposes. Now, think about corporate environments. Guest Wi-Fi can be a double-edged sword. By implementing a controlled access, companies can provide visitors with internet access while safeguarding sensitive data. It's about creating a welcoming atmosphere without compromising security. And then there's the BIOD trend. With employees bringing their own device, registration becomes essential. A streamlined process where compliant devices connect to the network, reducing vulnerabilities. This balance of convenience and security is key to fostering a productive environment. Each of these scenarios highlights the importance of smart access control in an increasingly connected world. Connecting to a network through a captive portal is a seamless experience. First, you grab your device, laptop or smartphone, and connect to the Wi-Fi. Almost instantly, your initial web requests are intercepted and redirected to the PacketFence captive portal. Here's where the magic happens. You're greeted with a login page or a registration form. Depending on the setup, you might enter your credentials, accept an acceptable use policy, or even register your device. Once you've completed that, PacketFence springs into action. It evaluates your input against predefined policies to determine your access level. You could be granted full access with specific roles or VLANs assigned, or in some cases, access might be denied, redirecting you for further action. This entire process ensures that network access is secure and controlled, especially in environments with guest users or BYOD policies. It's a smart way to keep the network safe while providing users the access they need. A user connects to the network via a device, e.g., laptop, smartphone. The device's initial HTTP/HTTPS requests are intercepted and redirected to the PacketFence captive portal. The user is presented with a login page or registration form. Depending on the configuration, this may involve entering credentials, e.g., username, password, accepting an acceptable use policy, AUP, or registering the device. Based on the user's input and predefined policies, PacketFence determines the appropriate access level, grant access and assign roles or VLANs, or deny access or redirect for further action. This process ensures secure and controlled network access, particularly in environments with guest users or bring your own device BYOD policies. In PacketFence, filter engines play a pivotal role shaping our network security landscape. Imagine these engines as vigilant gatekeepers, tirelessly inspecting every data that flows through the network. They don't get what's coming in. They manipulate and enforce policies based on the device's posture and complexity. When a device connects, the filter engine assesses its role, whether it's an employee or a rogue device. Depending on this assessment, it determines what actions are permissible. Can that device access sensitive data, or should it be quarantined? This dynamic enforcement ensures that only compliant devices enjoy full network privileges, while non-compliant ones are restricted, protecting the integrity of our network. In essence, these filter engines are the unsung heroes of network access control, ensuring that our digital environment remains secure and efficient. In PacketFence, filter engines play a pivotal role in shaping our network security landscape. Imagine these engines as vigilant gatekeepers, tirelessly inspecting every packet of data that flows through the network. PacketFence offers a variety of filter engines to enhance network security and control. First up is IP tables and IPsec, the backbone of inline enforcement. This Linux-based mechanism excels at VLAN isolation and role-based access control, effectively filtering or redirecting traffic in setups like inline bridges. Then we have PZOF, which takes a passive approach to overprinting. It identifies devices without any active probing, providing valuable data for filter decisions. Next, Snort and Suricata step in as powerful IDS/IPS solutions. While they don't filter direct, they detect malicious behavior and can trigger policy changes, keeping your network safe. DHCP fingerprinting is another tool. Client DHCP options to identify devices and assign roles that engines enforce. Finally, radius-based filtering shines in 802.1x and authentication bypass environments, returning VLANs and ACLs to switches and controllers for enforcement. Inline enforcement modules like IP tables, EB tables work seamlessly in these interfaces, allowing PacketFence to act as a transparent bridge, enforcing policies directly. Each of these engines plays a crucial role in creating a robust and secure network environment. As of the most recent versions, main filter engine by PacketFence. IP tables, Josh IPsec, is the default filtering mechanism for inline enforcement, working well in isolation and role access control. It uses IP tables and IP to filter or redirect traffic, and is common for inline enforcement setups, like inline bridges or inline interfaces. PSF is not a filter engine in itself, but provides data for filtering decisions, identifying devices, and OS without active probing, and is useful in conjunction with other engines to profile devices. Snort and Suricata are intrusion, detection, and prevention systems, IDS/IP, that can be integrated to detect malicious behavior and enforce restrictions. They are not used for filtering directly, trigger policy change. DHCP fingerprinting is based on DHCP options from clients to identify devices, and is used to assign roles which are then enforced by filter engines. Radius-based filtering 802.1 MAC authentication bypass environments, returning VLANs, ACLs, or role-based attributes to the network equipment like switches and wireless controllers. The actual enforcement happens on the switch, not within PacketFence itself. Inline enforcement modules like tables, EB tables, or NF tables are used in inline interfaces, allowing PacketFence to act as a transparent bridge between devices and the network, enforcing policies directly. In PacketFence, billing tiers are a game changer for managing net access. Imagine a guest network where users use their experience based on what. With billing tiers, administrators can set up different levels of access based on data quotas and bandwidth limits. For instance, you might offer a quick 1-hour pass with a 500 MB limit for casual use, or a full day of unlimited for those who need more. Each tier can even come with a price tag, making it easy to monetize your. Users can be assigned to automatically through a captive portal annually via vouchers. This flexibility not only enhances user experience, but also optimizes networks. So, whether it's for a bustling cafe or a campus, tiers in PacketFence ensure everyone gets the right access for their needs. In PacketFence, Billing tiers generally refers to a feature used in environments where network access is tied to usage-based billing or quota management. This is especially relevant in guest networks, educational institutions, or public Wi-Fi setups where users might pay for bandwidth, time, or data use. Billing tiers in PacketFence allow administrators to define different access levels based on duration, data quota, bandwidth limits, and price if charging is enabled. Each tier can be associated with a price and network access profile, and users can be assigned a tier either manually or automatically via captive portal registration or voucher. Example, use case, free tier, 1 hour access, 500 MB quota, 1 Mbps speed, $0. Premium tier, 1 day access, 5 GB quota, 10 Mbps speed, $5. In Packet, defining billing tiers is a breeze. Just head to the admin interface under Guest Management or Portal Settings. Here, you can easily assign each tier to specifics or vouchers. This is crucial because each role dictates access levels through VLANs, firewall rules, and even bandwidth shaping. It's all about control and customization, but it doesn't stop there. PacketFence keeps a close eye on user activity, tracking usage to ensure everyone stays within their limits. If users find themselves running low on time or data, they can seamlessly upgrade or recharge right through the captive portal. It's user-friendly and efficient, making sure everyone gets the most out of their experience while keeping the network secure and well managed. How it works in PacketFence. Define billing tiers in the admin interface under the guest management or portal settings. Assign to roles, talk, or vouchers. Each billing tier is linked to a which controls access level via VLAN, firewall rules, or bandwidth shaping. Track usage. PacketFence monitors users' usage and enforces limits. Recharge or upgrade. Users can upgrade or buy more data via the captive portal. Track usage. PacketFence monitors the user's usage and enforces limits. Recharge or upgrade. Users can upgrade or buy more time data via the captive portal. Visioning in PacketFence about automating the way to configure and register new devices on our network. Imagine a new device connecting. PacketFence springs into action, ensuring it meets our security policies before granting full access. This process starts with device identification, where PacketFence recognizes the type of device and its operating system. Next, it checks compliance with our security standards, ensuring antivirus software is up to date, or that the device has the latest patches installed. If everything checks out, the device is seamlessly registered and the user gains access to the network. If not, PacketFence can redirect them to a remediation portal, guiding them through the steps needed to comply. This automated approach not only enhances security, but also streamlines the onboarding process, making it efficient and user-friendly. In a world where security is paramount, provisioning in Packet is a game changer for network management. Provisioning in PacketFence refers to the automated process of configuring and registering new devices on the network so they comply with security policies before granting full access. Here's a high-level breakdown of what provisioning typically involves in PacketFence. Provisioning is crucial for maintaining a secure network. When a device connects, the first step is ensuring it's registered or authenticated. This means verifying the user or device to prevent unauthorized access. Next, we check compliance with security policies. This includes ensuring the operating system is up to date, software is active, and all patches are applied. This step is vital to fend off vulnerabilities. Finally, we assign the device to the correct VLAN or access level, ensuring it has the right permissions without compromising the network. By following these steps, we create a robust defense against potential threats while optimizing network performance. Provisioning is crucial for maintaining a secure network. When a device connects, the first step is ensuring it's registered or authenticated. When it comes to provisioning in PacketFence, we have two distinct approaches: out-of-band and in-band. With out-of-band provisioning, devices are redirected to a captive portal where users log in using methods like LDAP, Radius, or even social logins. This is where the magic happens. Devices are checked for compliance through agents or scripts. If everything checks out, PacketFence grants access, ensuring a secure environment. On the flip side, we have in-band provisioning. Here, PacketFence integrates directly with your switches, points, or controllers. This method allows for dynamic device classification and access control without the need for redirection. It's seamless and efficient, making sure that users get connected quickly while maintaining robust security. Both methods have their strengths, catering to different needs in network management. Imagine you can register your own devices seamlessly. With our device registration portal, you have the power to manage your devices effortlessly. Whether you prefer agentless or agent-based scanning, we ensure your operating system, patches, and antivirus status are always up to date. Network device profiling takes it a step further, utilizing DHCP fingerprinting, SNMP, and Mac OI to identify devices accurately. And for those corporate laptops you know and trust, they're automatically provisioned through our auto registration feature, saving you time and hassle. But what happens if a device doesn't comply? No worries. Our device isolation and remediation feature kicks in, placing non-compliant devices in a quarantine VLAN with clear instructions for resolution. It's all about keeping your network secure while empowering you to take control. Setting Fence on-premise is a big deal for network security. First, install the provisioning install package on CentOS or Alma Linux. Once that's done, configure your zones. Create your registration plan for new devices, a quarantine VLAN for those that need a checkup, and a production VLAN for your trusted devices. Next, enable the captive portal to guide us through the login process. Customize those login and registration pages to reflect your brand. Make it user-friendly. Now, let's dive into authentication sources. Integrate LDAP, Radius, SAML, OAuth to ensure secure access for everyone. Device profiling is crucial. Use DHCP fingerprinting and SNMP to identify devices accurately. Set compliance rules to check for OS versions, status, and blacklist any rogue devices. Finally, don't forget switch and controller integration. Configure 802.1x for secure access, SNMP for monitoring, and Radius CoA for dynamic VLAN. With these steps, you'll have a robust and secure network environment in no time. PacketFence is a powerful network access control solution that streamlines how we manage device access. At the heart of this system are portal modules, which are essential for creating user-friendly web portals. These portals play a crucial role when users connect to a network, like guest Wi-Fi. Imagine walking into a cafe and being seamlessly redirected to a captive portal where you can register or authenticate your device. These portals not only enhance security, but also improve user experience by guiding users through the access process. With customizable designs, organizations can tailor the look and feel to match their branding, making the experience both secure and engaging. So, whether it's for a quick guest login or a more complex authentication process, PacketFence's portal modules ensure that access control is efficient, effective, and user-centric. In PacketFence, a network access control (NAC) solution, portal modules are components that define and manage the behavior and appearance of web-based portals used for device registration, authentication, and access control. These portals are commonly presented to users when they connect to a network like a guest Wi-Fi and are redirected to a captive portal. PacketFence offers a variety of portal modules that cater to different network access needs. First up is the registration portal, where new devices can easily register. It supports methods like self-registration and sponsor approval, all controlled by policies based on roles or MAC addresses. Then we have the authentication portal, which ensures users are verified before accessing the network. It accommodates local accounts, radius, LDAP, SAML, and even social logins like Google and Facebook. Next is the remediation portal, a lifesaver for devices stuck in restricted VLANs due to policy violations. It guides users through fixing issues like outdated antivirus software. The guest access portal is perfect for visitors, offering temporary access through sponsor approvals or self-service options. For those in BYOD environments, the BYOD portal registers personal devices and installs necessary certificates. Finally, the pre-registration portal allows users or admins to register MAC addresses ahead of time, streamlining the access process. Each module plays a crucial role in maintaining network security while enhancing user experience. PacketFence includes several built-in portal modules, and administrators can customize or extend them as needed. Here are the main types. The registration portal is used to register new devices and can support multiple registration methods: self-registration, sponsor approval, SMS, email verification, etc., controlled by policies like roles, MAC addresses, or access durations. The authentication portal authenticates users before they gain network access and supports various authentication methods: local accounts, radius, LDAP, Active Directory, SAML, SSO, and social logins like Google and Facebook. The remediation portal is used when a device placed in a restricted VLAN due to policy violations, such as outdated antivirus or malware presence, and guides users on how to fix issues before regaining full access. The guest access portal is typically for temporary access by visitors and includes sponsor-based approvals or self-service portals, which can be combined with ticketing or SMS email validation. The BYOD portal is for bring your own device environments, registering personal devices and installing necessary certificates or agents. Lastly, the pre-registration portal allows users or admins to pre-register MAC addresses or devices before network access is attempted. Customization and configuration portal modules are essential for tailoring user experiences. In the admin GUI, you'll find everything under Configuration Portal. For deeper tweaks, dive into the configuration files located in QSR local PFF-conf, particularly captiveportal.conf and portal.conf. These modules leverage HTML templates and Perl backend scripts to shape both behavior and layout. Want to give your portal a fresh look? Customize the appearance through themes found in QSR local PF HTML captive portal themes. You can easily add or modify fields, branding, and flow logic to suit your needs. Consider a corporate guest Wi-Fi access scenario. A user connects to the Wi-Fi and is redirected to the guest portal. They fill out a self-registration form, and voila, an email validation link is sent. Once they verify their email, access is granted for 24 hours. This seamless process enhances user experience while maintaining security. Customization truly empowers your portal to meet specific requirements. Access duration in PacketFence is a crucial concept that determines how long a device can stay connected to the network after authentication. Imagine you've just logged in and you're granted access. This is where access duration kicks in. It's like having a VIP pass to a concert. You get to enjoy the show, but only for a limited time. This duration can vary based on policies set by network administrators. For instance, a guest might have just a few hours, while a full-time employee could have access for days or even weeks. This flexibility helps maintain security while ensuring users can get their work done without unnecessary interruptions. If your time is about to expire, you might receive a notification prompting you to re-authenticate or request an extension. This dynamic approach not only enhances security, but also ensures that the network remains efficient and responsive to the needs of its users. So, next time you log in, remember, your access duration is your ticket to staying connected. Access duration in PacketFence is a crucial aspect of network management. It defines how long a device can stay connected after authentication. For instance, when a guest registers, their access duration might be set to 24 hours, allowing them to enjoy the network without interruptions. In web-based captive portals, you can customize access durations for different user types. Students might have access only during school hours, while staff could enjoy more flexible connectivity. This feature also ties into role enforcement. Specific roles come with preset time limits. Imagine a device that, once registered and approved, gains permanent access. This flexibility ensures that network resources are used efficiently while maintaining security and control. Access duration is all about balancing convenience and management, making it a key player in network access strategies. In PacketFence, access duration refers to the amount of time a network device, user, is allowed to remain on the network after being granted access, typically through some form of authentication or registration. Where access duration is used, guest access. When a guest registers or is registered by a sponsor, the access duration determines how long that guest can remain connected to the network before needing to re-authenticate or re-register. Portal configuration. In web-based captive portals, you can configure access durations for various user types, e.g., students, guests, staff. Role policy enforcement. Access duration can be tied to a role, meaning users assigned a specific role will have a preset time limit for access. Examples. A guest might get 24-hour access after registering. A student might have access during school hours only. A device might be allowed permanent access once registered and approved. PacketFence is a powerful tool that ensures network security by meticulously tracking session start times. Once your session hits the time limit, it takes action, either disconnecting you or redirecting you back to a portal for re-authentication. This means that if you're logged in for too long, you won't just be left hanging. Instead, you'll be prompted to verify your identity, keeping the network safe from unauthorized access. It's like having a vigilant guardian that ensures only the right people stay connected. So whether you're streaming, working, or browsing, you can trust that PacketFence is working behind the scenes to maintain a secure environment, all while keeping your experience seamless. PacketFence keeps track of session start times and removes or revalidates network access once the time limit expires, either by disconnecting the session or redirecting back to a portal for re-authentication. In PacketFence, self-service is a game changer for network users. Imagine being in a busy school or a bustling office, and you need to connect to the Wi-Fi. Instead of waiting for an admin to help you out, you can take control. With self-service, you can unlock your account, reset your password, or even manage your device's access, all on your own. This feature not only saves time, but also empowers users to resolve issues instantly, reducing frustration and keeping everyone connected. In environments like public Wi-Fi networks, this means quicker access for everyone, enhancing the overall experience. Self-service in PacketFence is all about making network access seamless and efficient, putting the power right in your hands. In PacketFence, self-service refers to a feature that allows end users, network users, to perform certain actions related to their network access without needing administrator intervention. This is particularly useful in environments like schools, enterprises, or public Wi-Fi networks, where users may need to connect to the Wi-Fi. Instead of waiting for an admin to help you out, you can take control. With self-service, you can unlock your account, reset your password, or even manage your device's access, all on your own. This feature not only saves time, but also empowers users to resolve issues instantly, reducing frustration and keeping everyone connected. In PacketFence, self-service empowers users to manage their network access seamlessly. Imagine registering your personal devices, like your laptop or smartphone, without waiting for an admin. You simply enter your MAC address or log in with your credentials on a user-friendly portal. Need to reset your password? No problem. If your network uses LDP or Active Directory, you can change it on your own. Before connecting, you'll agree to the acceptable use policy, ensuring everyone's on the same page. Want to manage your devices? You can easily view, edit, or delete your registered devices whenever you need. If you have guests, they can request access, and with SMS or email validation, you can sponsor them securely. And for those who love bringing their own devices, the BIOD onboarding process guides you through connecting safely. With these features, PacketFence makes network access a breeze, putting you in control. In PacketFence, self-service refers to a feature that allows end users, network users, to perform certain actions related to their network access without needing administrator intervention. This is particularly useful in environments like schools, enterprises, or public Wi-Fi networks where users may need to. Common self-service features in PacketFence: device registration. Users can register their personal devices, laptops, phones, etc. to gain network access. Often includes a portal where they input details like MAC address or log in with credentials. Password management. Reset or change passwords for accessing the network, if integrated with a directory like LDAP or Active Directory. Acceptable use policy AUP. Agree to terms of service before gaining network access. Device management. View, edit, or delete previously registered devices. Guest access. Request guest access or sponsor approval. Can include SMS or email validation for identity. BYOD, bring your own device. Onboarding. Guided process to securely connect user-owned devices to the network. Imagine a world where IT teams can breathe a little easier. By automating common support tasks, we're not just reducing their workload, we're freeing them up to tackle more complex issues. Think about it. Users can get online faster, enhancing their experience and productivity. Plus, with robust security measures in place, we're enforcing policies before granting access, ensuring that only the right people are on the network. This isn't just about convenience. It's about creating a safer, more efficient environment for everyone. If you're looking to set up or customize the self-service portal in PacketFence, let's dive in and make it happen. In PacketFence, the network settings are the backbone of effective communication between the server and various network devices. Think of them as the control center for switches, wireless controllers, DHCP servers, and DNS. Each parameter plays a vital role in ensuring seamless network access control. For instance, configuring your DHCP settings allows PacketFence to manage IP address assignments dynamically, ensuring devices connect smoothly. Meanwhile, the integration with switches enables real-time enforcement of access policies, keeping unauthorized users at bay. Don't forget about the DNS settings. They help resolve host names, making it easier for devices to communicate. By fine-tuning these components, you create a robust network environment that not only enhances security but also optimizes performance. Remember, every detail in these settings contributes to a well-oiled network machine. In PacketFence, the network settings refer to the configuration parameters that control how the PacketFence server communicates with other devices on the network, such as switches, wireless controllers, DHCP servers, DNS, and more. These settings are crucial for proper network access control and enforcement. Here's a breakdown of key components within PacketFence's network settings. PacketFence is all about seamless network management, and it achieves this through its multiple network interfaces, each with a dedicated role. First up, the management interface. This is your gateway to the web GUI, where you can oversee everything with ease. Then we have the isolation interface, which is crucial for quarantining unregistered devices, keeping your network secure. Next, the registration interface is where users get redirected to register their devices, ensuring that only authorized devices get access. If you're implementing inline enforcement, the inline interface comes into play, bridging traffic and maintaining control over your network flow. Lastly, the SNMP interface allows for smooth communication with switches and controllers, making network monitoring a breeze. Each interface plays a vital role in creating a robust and secure network environment, ensuring that everything runs smoothly and efficiently. PacketFence typically uses multiple network interfaces, each assigned a specific role. Management interface, for administrative access to the web GUI and backend management. Isolation interface, for quarantined or unregistered devices. Registration interface, where users are redirected to register their devices. Inline interface, if using inline enforcement, e.g., bridging traffic. SNMP interface, for communicating switches, controllers via SMP. Each interface in our network needs a unique IP address and subnet mask. This isn't just a technical detail, it's essential for directing traffic efficiently, enforcing security policies, and ensuring seamless communication with the endpoints. Now, let's dive into VLAN configuration. PacketFence operates in VLAN enforcement mode, dynamically assigning VLANs for registered and quarantined devices. This means switches can adjust VLAN assignments based on radius responses from PacketFence, enhancing network security and management. Then we have DHCP and DNS integration. PacketFence can function as a DHCP server on specific interfaces or work alongside an existing DHCP setup. And don't underestimate DNS. It plays a crucial role in redirecting users to the captive portal. When users attempt to browse the internet before registering, DNS redirection ensures they land on the right page. This integration not only streamlines user experience, but also fortifies network security. Understanding these components is key to maintaining a robust network infrastructure. Each interface needs an IP address and subnet mask. Proper IP configuration is critical for redirecting traffic, enforcing policies, and communicating with endpoints. PacketFence often works in VLAN enforcement mode, defining VLANs for registered devices, quarantined devices, registration, and remediation. The switches will change VLAN assignments based on radius responses from PacketFence. PacketFence can act as a DHCP server on specific interfaces or integrate with an existing DHCP server. DNS is required for redirecting users to the captive portal, with DNS redirection when users try to browse the internet before registering. When integrating wireless controllers with PacketFence, the first step is configuring essential network settings. You'll need to input the controller IPs and SMP credentials to ensure smooth communication. Next, set up your Radius server settings, including the listening ports. Default are 1812 and 1813, and shared secrets for secure communication with your switches and controllers. Don't overlook the authentication realms. Integrating with Active Directory or LDAP can streamline user management. Access control settings are crucial too. Define how and when to enforce restrictions, utilizing MAC detection and health checks to maintain network integrity. If this is your first time configuring PacketFence, the Admin GUI's configuration wizard is a lifesaver, guiding you through the basics. Once you're set up, you can refine everything under configuration. Network. It's all about creating a secure, efficient wireless environment. Network settings also include how PacketFence handles radius requests, listening ports, default 1812, 1813, and shared secrets for communicating with switch controllers. Definitions for how and when to enforce access restrictions, e.g., MAC detection, health checks, ACLs, and firewall rules. If you're configuring PacketFence for the first time, the Admin GUI provides a configuration wizard to guide through basic network settings. You can later refine everything through the Admin GUI under Configuration, Network. In PacketFence, interfaces are the lifelines of our network. Think of them as the gateways that allow us to control and monitor every device trying to connect. Each interface plays a crucial role in ensuring the network remains secure and efficient. When a device attempts to join, PacketFence uses these inputs to assess its compliance with our security policies. If it passes the checks, it gets access. If not, it's quarantined. This dynamic management of interfaces not only enhances safety, but also optimizes network performance. By fine-tuning these connections, we can ensure that interfaces that the system uses to control and monitor network traffic for devices connecting to the network. PacketFence is a network access control (NAC) solution, and managing interfaces correctly is essential for it to function properly. In the world of PacketFence, understanding key interface types is crucial for effective management. First, we have the management interface, typically ET0, which is essential for administrative access via the web GUI or SSH. This interface must be isolated from the captive portal and inline traffic to ensure security. Speaking of inline traffic, when PacketFence operates in bridge or router mode, it can monitor and control traffic directly by bridging interfaces, allowing for real-time policy enforcement. Then there's the SNMP interface, which plays a vital role in communicating with network switches and access points for device registration and VLAN assignments. If PacketFence is acting as a DHCP server, the DHCP interface comes into play, assigning IPs and enforcing access control based on the device state. Lastly, web portal interface is where users are redirected for authentication or registration, making it a critical touchpoint for user interaction. In a typical setup, you might see ET1 and ET2 bridged together for inline enforcement, while VLAN tagging helps separate various network access types, like registration, quarantine, and production VLANs. Each key interface type in PacketFence includes the management interface, used for administrative access to PacketFence, which should be isolated from captive portal or inline traffic. The inline interface, used to monitor or control traffic directly, where PacketFence may bridge two interfaces to inspect and enforce policies on network traffic. The SNMP interface, used to communicate with network switches and access points for device registration and VLAN assignment. The DHCP interface, used if PacketFence is acting as a DHCP server to assign IPs and enforce access control based on device state. And the web portal interface, which handles the captive portal where users are redirected for authentication or registration. In a typical setup, ETH0 might be the management interface, while ETH1 and ETH2 could be bridged together for inline enforcement, and VLAN tagging might be used to separate different types of network access, such as registration VLAN, quarantine VLAN, and production VLAN. Interfaces are the backbone of PacketFence, and their proper configuration is crucial. When interfaces are set up correctly, we ensure accurate enforcement of network access policies, which means only authorized devices get in. This is vital for maintaining security. Moreover, proper device detection and isolation becomes seamless, allowing us to quickly identify and manage devices on the network. Imagine a scenario where a rogue device tries to connect. With the right interface setting, we can isolate it before it causes any harm. And let's not forget the user experience. A well-configured interface leads to a smooth captive portal experience, making it easy for users to authenticate without frustration. Lastly, secure administrative access to the NAC system is paramount. With the right interfaces, we protect our management tools from unauthorized access, keeping our network safe and sound. In short, interfaces matter because they are the gatekeepers of a secure and efficient network environment. Correct interface configuration ensures accurate enforcement of network access policies, proper device detection and isolation, seamless user experience via the captive portal, and secure administrative access to the NAC system. In PacketFence, inline mode is a game changer for network security. Imagine having the PacketFence server right in the traffic path between users and the network. This setup gives us complete visibility and control over every packet that flows through. With this power, we can enforce robust security policies seamlessly. Captive portal redirection ensures users authenticate before accessing resources, while traffic filtering with firewall rules keeps unwanted data at bay. Plus, we can dynamically assign VLANs based on user or device compliance, ensuring only authorized devices connect. Inline mode transforms how we manage network access, making it smarter and more secure. It's all about creating a safer digital environment for everyone. In PacketFence, inline mode refers to one of the deployment architectures where the PacketFence server is placed directly in the path of network traffic between users and the rest of the network. This gives PacketFence full visibility and control over all traffic going through it, enabling it to enforce security policies such as captive portal redirection, traffic filtering via firewall rules, VLAN assignment, and network access control based on user device compliance. Inline mode with PacketFence is a game changer for network security. Acting as a Layer 2 or Layer 3 bridge or router, it ensures that all user traffic flows through the PacketFence server. This means every packet is inspected, and any unauthenticated or non-compliant devices are seamlessly redirected to a captive portal. Once users authenticate and meet compliance standards, they can access the network normally. The advantages are clear. You gain full control over user traffic, even with non-802.1x capable switches. You can enforce policies without needing to tweak external switch configurations. However, it's not without its challenges. It can become a single point of failure, although high availability setups can mitigate that risk. Plus, since all traffic must pass through PacketFence, you may experience some added latency, and the network design can get a bit complex with bridge interfaces and routing. This setup is particularly useful for smaller networks without managed switches or guest Wi-Fi networks where redirecting users to a captive portal is essential. It's a robust solution for environments lacking 802.1x support, ensuring that security and compliance are always top of mind. How inline mode works. PacketFence acts as a Layer 2 or Layer 3 bridge router. All user traffic must pass through the PacketFence server. It inspects the traffic and redirects unauthenticated or non-compliant devices to a captive portal. Once devices are authenticated and compliant, they are allowed to pass through normally. Advantages of inline mode. Full control over user traffic. Works well even with non-802.1x capable switches. Can enforce policies without relying on external switch configuration. Disadvantages. May become a single point of failure. Can be mitigated with high availability setups. Adds latency since all traffic must pass through PacketFence. More complex network design, bridge interfaces, routing, etc. Typical use case. Smaller networks without managed switches. Guest Wi-Fi networks where redirecting to a captive portal is necessary. Environments without 802. In PacketFence, fencing is a crucial part of keeping our network secure. Imagine a device acting suspiciously. Maybe it's infected with malware or simply not following our policies. Fencing kicks in to isolate that device, preventing it from causing chaos on the network. This process is vital for maintaining compliance and protecting sensitive data. By restricting access, we can investigate and resolve issues without compromising the entire network. It's like having a security guard who spots trouble and swiftly removes the threat, ensuring that the rest of us can work safely and efficiently. Fencing isn't just about isolation. It's about safeguarding our digital environment and maintaining trust in our network. In PacketFence, fencing refers to the process of isolating or restricting a device, node, on the network when it is deemed non-compliant or suspicious, such as being infected, misbehaving, or violating policies. It is part of PacketFence's network access control, NAC mechanisms. In PacketFence, fencing is a crucial process that helps keep our networks safe. Imagine a device acting suspiciously. Maybe it's infected or just not following our rules. That's when fencing kicks in. It's all about protecting the network by isolating those problematic devices. Fencing can be triggered by several events: a failed antivirus check, detection of malicious behavior like port scans, or even simple policy violations like not accepting the terms of use. Once a device is flagged, we take immediate action. It might be redirected to a remediation VLAN or a captive portal, restricting its access to the internet or internal resources. In some cases, we even place the device into quarantine. This proactive approach ensures that our network remains secure and compliant, allowing only trusted devices to connect. Fencing is not just a safety measure. It's a vital part of maintaining the integrity of our entire network. In PacketFence, fencing refers to the process of isolating or restricting a device, node, on the network when it is deemed non-compliant or suspicious, such as being infected, misbehaving, or violating policies. It is part of PacketFence's network access control, NAC mechanisms. Key points about fencing in PacketFence. Purpose: to protect the network by limiting or blocking access of problematic devices. Triggers: fencing can be triggered by events such as failed antivirus or patch checks, detection of malicious behavior, e.g., port scans, abnormal traffic, policy violations, e.g., not accepting terms of use. Actions taken: redirecting the user to a remediation VLAN or a captive portal, restricting access to the internet or other internal resources, placing the device into quarantine. Fencing PacketFence is all about safeguarding our network by managing access for devices that pose a risk. Imagine a device that fails antivirus checks or exhibits suspicious behavior, like port scans or unusual traffic patterns. That's where fencing kicks in. It's triggered by these red flags, ensuring we maintain a secure environment. When a device misbehaves, it can be redirected to a remediation VLAN or a captive portal, restricting its access to the internet or internal resources. We have different types of fencing: registration fencing for new devices that need to register before connecting, violation fencing for those that break our rules, and remediation fencing for devices that require updates. This dynamic and automated response keeps our network compliant and secure, allowing us to focus on what matters while ensuring only trusted devices gain access. Fencing in PacketFence is designed to protect the network by limiting or blocking access of problematic devices. Fencing can be triggered by events such as failed antivirus or patch checks, detection of malicious behavior like port scans or abnormal traffic, and policy violations such as not accepting terms of use. Actions taken include redirecting the user to a remediation VLAN or captive portal, restricting access to the internet or other internal resources, and placing the device into quarantine. There are 3 types of fencing: registration fencing for new or unknown devices that must register before accessing the network, violation fencing when a device breaks a rule or policy, and remediation fencing for devices needing updates or fixes. Fencing is a dynamic and automated response, helping maintain a secure and compliant network. In PacketFence, device parking is a crucial feature that acts like a temporary timeout for devices misbehaving on the network. Imagine a scenario where a device is non-compliant or poses a security risk. Instead of letting it roam freely, PacketFence steps in to quarantine it, restricting access until the issue is resolved. This is essential in network access control, ensuring that only compliant devices can connect. It's like having a bouncer at a club, checking IDs and making sure everyone inside is safe. By managing these devices effectively, we maintain a secure and efficient network environment, allowing compliant devices to thrive while keeping the troublemakers at bay. In PacketFence, device parking is a feature used to temporarily restrict or In PacketFence, device parking is a crucial feature that acts like a temporary timeout for devices misbehaving on the network. In PacketFence, device parking is a crucial feature for maintaining network security. When a device is parked, it enters a quarantine state, meaning it's placed in a VLAN with limited or no access. This isolation helps protect the network from potentially harmful or non-compliant devices. Parking can happen manually by an administrator or automatically when a device violates policies, like failing posture checks or showing suspicious behavior. Once parked, users often encounter a captive portal that explains the reason for the restriction and outlines steps for remediation, such as updating antivirus software or agreeing to acceptable use policies. level. When a device is parked in PacketFence, it's like being put in timeout for a good reason. This quarantine state means the device is moved to a special VLAN with limited or no network access, isolating it from the rest of the network. It can happen manually by an admin or automatically if it violates policies, like failing a posture check or showing suspicious behavior. Once parked, the device encounters a captive portal that explains why it's there and offers steps for remediation, like updating antivirus software or accepting acceptable use policies. The best part? Parking isn't permanent. Once the issues are resolved, the device can be unparked and restored to full access. This process is crucial for maintaining network security, especially when dealing with potential threats, rogue devices, or compliance failures. It's all about keeping the network safe while giving users a clear path to regain their access. Device parking means, in PacketFence, quarantine state. When a device is parked, it is placed into a special VLAN or role that has very limited or no network access. This helps isolate potentially harmful or non-compliant devices from the rest of the network. Manual or automatic. Devices can be parked either manually by an administrator or automatically based on policy violations, e.g., failed posture checks, antivirus not up to date, suspicious behavior. Remediation process. Once parked, the device may be presented with a captive portal that explains why it was parked and possibly provides steps for remediation, e.g., updating antivirus, accepting acceptable use policies. Non-permanent. Parking is typically a temporary measure. Once the issue is resolved, the device can be unparked and restored to its normal access level. Use cases for parking a device. Security threats or vulnerabilities detected. Unknown or rogue devices appearing on the network. Devices that fail compliance checks during troubleshooting or audits. Now for devices misbehaving on the network. In PacketFence, SNMP is the heartbeat of network access control. Imagine it as the communication bridge between our management system and the various network devices, switches, routers, and wireless access points. This protocol allows us to detect every device connecting to the network, ensuring we know who's in our digital space. When a new device tries to join, SNMP sends alerts, helping us enforce security policies in real time. It's not just about monitoring, it's about actively managing our network. With SNMP, we can gather vital statistics, troubleshoot issues, and even configure devices remotely. This seamless interaction empowers us to maintain a secure and efficient network environment, making sure that only authorized users gain access. In essence, SNMP transforms our network management from reactive to proactive, keeping our infrastructure robust and secure. In PacketFence, SNMP, Simple Network Management Protocol, plays a key role in network access control by enabling the system to interact with network hardware like switches, routers, and wireless access points for detecting and managing devices on the network. In PacketFence, SNMP is like the heartbeat of network access control. Imagine it as the communication bridge between our management system and the various network devices, switches, routers, and wireless access points. SNMP plays a crucial role in how PacketFence integrates with network devices. It communicates seamlessly with switches and wireless controllers, enabling essential port security actions like enabling or disabling ports and assigning VLANs. Imagine a network that can automatically detect rogue devices or IP spoofing. This is made possible through SNMP's ability to query devices for vital information like MAC addresses and port status. When a device connects, PacketFence can dynamically assign it to a quarantine VLAN if it's unregistered, ensuring that only authorized devices access the network. Plus, with SNMP traps and polling, we can monitor network health in real time, receiving alerts about device status and potential issues. This proactive approach not only enhances security, but also streamlines network management, making it easier to maintain a robust and secure environment. PacketFence uses SNMP to communicate with switches and wireless controllers. It performs port security actions such as enabling, disabling ports, VLAN assignment, and device fingerprinting. SNMP is used to query network devices to gather information about connected endpoints, MAC addresses, port status, etc. It helps in detecting rogue devices, IP MAC spoofing, and unauthorized network access. SNMP allows PacketFence to dynamically assign VLANs to ports based on endpoint status, e.g. quarantine VLAN for unregistered devices. SNMP traps or polling can be used for monitoring network health and device status. To enable SNMP and PacketFence. In PacketFence, floating devices are a game changer for network management. Imagine a loaner laptop that seamlessly shifts from one user to another, adapting to their needs without missing a beat. These devices, like shared tablets or guest devices, are designed for flexibility. They're perfect for environments like libraries or labs, where multiple users need access without the hassle of permanent assignments. This not only optimizes resource use, but also enhances security, as each device can be monitored and managed effectively. With floating devices, we're not just sharing technology. We're creating a dynamic, collaborative space that empowers users while maintaining a robust network. It's all about making technology work for everyone, anytime, anywhere. In PacketFence, a floating device refers to a device that is not permanently assigned to a specific user or location, and instead floats between different users or areas of the network. These devices may be used by multiple users at different times, such as loaner laptops, shared tablets, guest devices, and library or lab computers. In PacketFence, floating devices are a game changer for network management. Imagine a loaner laptop that seamlessly shifts from one user to another, adapting to their needs without missing a beat. Floating devices in PacketFence are a game changer for network management. Imagine a scenario where multiple users share the same device. This is where floating devices shine. By reducing registration friction, we streamline access for everyone. No more tedious signups for each user. They can jump right into the network. But it doesn't stop there. With floating devices, we can apply tailored network policies or VLANs, ensuring that each device gets the right level of access based on its use case. This flexibility allows us to track device usage patterns effectively, giving us insights into how shared or public systems are utilized. In PacketFence, a floating device isn't tied to a specific user account. It can be automatically registered or even bypass standard authentication, depending on how we configure it. Admins have the power to tag or classify these devices easily through PacketFence UI or API, making management a breeze. This approach not only enhances security, but also improves user experience, making network access faster and more efficient for everyone involved. PacketFence allows administrators to manage floating devices differently from personal or permanently assigned devices. This is useful for reducing registration friction, applying different network policies or VLANs, tracking device use patterns, and allowing quicker access to the network for shared or public systems. A floating device may not be tied to a specific user account in the usual way. It may be automatically registered or bypass standard authentication, depending on your configuration. Admins can tag or classify a device as floating in the PacketFence UI or via API. In PacketFence, alerting is like having a vigilant guardian watching over your network 24/7. Imagine receiving instant notifications whenever a security event or policy violation occurs. This feature is crucial for maintaining the integrity of your network. When a rogue device tries to connect or a policy is breached, PacketFence springs into action, sending alerts to administrators or other systems. This real-time visibility allows us to respond swiftly, mitigating risks before they escalate. With PacketFence, we're not just reacting to threats, we're proactively securing our environment, ensuring that our network remains healthy and resilient against potential breaches. It's all about staying one step ahead in the ever-evolving landscape of network security. In PacketFence, alerting refers to the system's capability to notify administrators or other systems when specific network security events or policy violations occur. PacketFence is a network access control (NAC) solution, and alerting is a key feature for maintaining visibility into the health and security of your network. In PacketFence, alerting is like having a vigilant guardian watching over your network 24/7. Imagine receiving instant notifications whenever a security event or policy violation occurs. This feature is crucial for maintaining the integrity of your network. PacketFence is a powerful tool for monitoring network activities, ensuring your environment stays secure. It detects rogue devices, MAC spoofing, unauthorized access, and failed authentication attempts. When a predefined rule is triggered, you receive instant alerts through various channels like email, syslog, SNMP traps, or even webhooks. You can easily configure these alerting rules right from PacketFence admin GUI or dive into the configuration files for more control. Alerts can be filtered and prioritized, so you only get notified about critical events. This helps in quickly identifying potential threats, enforcing compliance, and troubleshooting network issues. What's even more impressive is the integration with automatic remediation actions. Imagine isolating a device to a quarantine VLAN or triggering an endpoint scan, all automatically. PacketFence not only alerts you, but also empowers you to take swift action, keeping your network safe and sound. PacketFence monitors network activities such as rogue device detection, when a predefined rule is triggered, an alert is generated. You can configure alerting rules in the PacketFence admin GUI or directly in configuration files. Alerts can be filtered, prioritized, or suppressed based on specific criteria, like only notifying for critical events. Use cases include quickly identifying potential threats, enforcing compliance, and troubleshooting network issues. Alerts can be tied to automatic remediation actions, like isolating a device to a quarantine VLAN, triggering an endpoint scan, or blocking access. In PacketFence, maintenance tasks are the unsung heroes of system performance. Picture this: automated jobs running in the background, tirelessly cleaning up old data, optimizing our databases, and ensuring everything runs like a well-oiled machine. These tasks are crucial for stability and compliance. Think about it. Regularly purging outdated logs prevents clutter, while optimizing performance keeps our system responsive. We're talking about scheduled backups that safeguard our data and checks that ensure our configurations are up to date. Even routine audits help us stay compliant with security standards. Each task, whether manual or automated, plays a vital role in the long-term health of PacketFence, allowing us to focus on what really matters, providing seamless network access and security. So, let's appreciate these behind-the-scenes operations that keep our systems robust and reliable. In PacketFence, maintenance tasks refer to automated or manual background jobs designed to keep the system running smoothly by cleaning up old data, optimizing performance, and ensuring stability and compliance. These tasks are essential for long-term operation and can include things like in PacketFence, maintenance tasks are the unsung heroes that keep our system running like a well-oiled machine. Think of them as the diligent caretakers of our network. First up, we have database cleanup, which sweeps away old logs and expired sessions, freeing up space and boosting performance. Then there's Radius and DHCP lease cleanup, ensuring we only keep valid sessions and leases, which is crucial for efficiency. Log rotation and archiving play a vital role too, compressing logs to prevent disk space from vanishing into thin air. And let's not forget about certificate expiration checks. These keep us on our toes, alerting us before any critical certificates expire. Session and node expiry checks ensure that inactive clients don't linger on our access lists, while file system cleanup gets rid of outdated backups and temporary files, conserving precious disk space. Finally, alert triggers and health monitoring keep a watchful eye on system components, catching errors and performance dips before they become issues. These maintenance tasks are essential for stability and compliance, ensuring PacketFence runs smoothly day in and day out. In PacketFence, maintenance tasks refer to automated or manual background jobs designed to keep the system running smoothly by cleaning up old data, optimizing performance, and ensuring stability and compliance. These tasks are essential for long-term operation and can include things like database cleanup, which removes old logs, expired sessions, or outdated nodes from the database to free up space and maintain performance. Radius and DHCP lease cleanup, which delete expired DHCP leases or stale Radius sessions that are no longer valid. Log rotation and archiving, which rotates and compresses logs to prevent the system from running out of disk space. Certificate expiration checks, which notify admins or perform actions if certificates used in the system are close to expiring. Session and node expiry checks, which ensure that inactive or expired network clients are properly removed from access lists. File system cleanup, which deletes old temporary files or outdated backups to conserve disk space. And alert triggers and health monitoring, which periodically checks system components for errors, performance degradation, or suspicious activity. Maintaining PacketFence is crucial for optimal performance. First up, database cleanup. This task removes old logs, expired sessions, and outdated nodes, freeing up space and keeping everything running smoothly. Then we have Radius and DHCP lease cleanup, which eliminates expired leases and stale sessions, ensuring our network remains efficient. Log rotation and archiving come next, compressing logs to prevent disk space issues. Certificate expiration checks are vital. They notify admins when certificates are nearing their end, so we never face unexpected downtime. Session and node expiry checks help us keep our access lists tidy by removing inactive clients. File system cleanup is equally important, as it clears out old temporary files and outdated backups to conserve disk space. Lastly, alert triggers and health monitoring regularly check system components for errors or performance issues, keeping us one step ahead. All these tasks are managed through the PF cron system, configuration files, or the web admin interface, making maintenance straightforward and efficient. Maintaining PacketFence is crucial for optimal performance. First up, database cleanup. This task removes old logs, expired sessions, and outdated nodes, freeing up space and keeping everything running smoothly. Then we have Radius and DHCP lease cleanup, which eliminates expired leases and stale sessions, ensuring our network remains efficient. Fence services are the unsung heroes of network access control. Picture this: a seamless orchestra of software components and daemons, all working tirelessly in the background. They detect devices they connect, ensuring only authorized users gain access. If a rogue device tries to sneak in, these services spring into action, isolating it before it can cause any harm. Authentication is a breeze, thanks to the robust mechanisms in place, verifying users and devices with precision. And let's not forget about management. These services provide real-time insights, allowing you to monitor and control your network effortlessly. It's like having a security team that never sleeps, ensuring your network remains safe and efficient. With PacketFence, you're not just managing devices. You're orchestrating a secure digital environment. In PacketFence, services refers to the various software components and daemons that run in the background to provide the full range of network access control (NAC) features. These services work together to detect, isolate, authenticate, and manage devices on your network. PacketFence operates through a suite of essential services that work seamlessly to ensure robust network access control. At the heart of it, we have the authentication services like PF.auth, which manages user and device authentication through Radius and 802.1x. The PF.radiusd daemon takes care of the Radius protocol for both 802.1x and MAC authentication, ensuring secure access. Then we have our web services. PF. httpd.admin provides a user-friendly interface for managing PacketFence, while PF. httpd.portal engages users through the captive portal for registration and login. On the network integration side, PF. DHCPD assigns IP addresses and detects devices, while PF. DNS handles redirection in the captive portal. Firewall management is handled by PF.iptables, ensuring that our network remains secure. For policy and detection, PF. Snort and PF. Suricata act as our vigilant IDS IPS, while PF. Fingerbank helps us identify devices by their operating systems. Maintenance is streamlined with PF. PFDHCP listener and PF. PFDNS listener, which monitor DHCP and DNS traffic for new devices and behavioral analysis. Lastly, integration with external services is made easy with PF. AD sync and PF. Dial DAP pipe sync, allowing us to sync user information from Active Directory and LDAP. All these services can be monitored and managed through the PacketFence web admin interface or via command line tools like systemctl and pfctl. Each component plays a crucial role in maintaining a secure and efficient network environment. PacketFence services refers to the various software components and daemons that run in the background to provide the full range of network access control features. These services work together to detect, isolate, authenticate, and manage devices on your network. Here's a breakdown of key PacketFence services and what they do. PF Auth handles user and device authentication via Radius 802.1x, captive portal, etc. PF Radius D, Radius daemon for 802.1x and MAC authentication. PF httpd.admin, the web admin interface for managing PacketFence. PF httpd.portal, the captive portal for user interaction, registration, login. PF IP tables, firewall rule management using IPs or NF tables. PF Snort, PF Suricata, intrusion detection prevention system. PF Fingerbank, device fingerprinting for OS and type detection. PF PFDHCP listens to DHCP traffic to detect new devices. PF PFDN listens to DNS traffic for behavioral analysis. PF PFCRON handles scheduled jobs and maintenance tasks. PF PEFQ, message queue processor that ties components together. PF AD sync, sync with Active Directory for user input. PF LDAP piped sync, LDAP integration for user authentication and sync. You can view, stop, or monitor these services through the PacketFence web admin under System Status Call Services, or the command line with systemctl or pfctl. In PacketFence, the database is the backbone of our network access control system. It meticulously stores and manages everything from connected devices, think MAC addresses, IPs, and host names, to detailed device fingerprints and user authentication details from Radius and captive portals. Configuration settings are also housed here, including VLANs, roles, and policies, along with switch and access point configurations and portal customization settings. But that's not all. It keeps a comprehensive log of events, capturing Radius authentication logs, DHCP and DNS events, and even violation and remediation logs for incidents like virus detection or policy breaches. For those who need to stay compliant, it provides historical access records and admin action logs, making reporting and auditing a breeze. PacketFence runs on MariaDB, a robust MySQL-compatible relational database, which can be deployed in standalone mode for simplicity or clustered mode for high availability and scalability. This ensures that your network access control remains efficient and reliable, no matter the demands. In PacketFence, the database is a crucial backend component used to store and manage all the system's configuration, operational data, and logs related to network access control. What the database in PacketFence does: stores network access information, connected devices, MAC addresses, IPs, host names, device fingerprints, user authentication details from Radius, captive portal, etc. Configuration settings, VLANs, roles, policies, switch and access point configurations, portal customization settings, logs and events, Radius authentication logs, DHCP DNS events, violation and remediation logs, e.g., virus detection, policy violations, reporting and auditing, historical access records, compliance reports, admin action logs. What kind of database does PacketFence use? PacketFence uses MariaDB, a MySQL-compatible relational database by default. This can be set up in standalone mode, single server deployment, clustered mode for high availability and scalability. In PacketFence, a cluster is like a well-oiled machine, where multiple servers join forces to ensure high availability and seamless performance. Imagine a network environment so large that even a moment of downtime could spell disaster. That's where clustering shines. By distributing the load across several servers, we not only enhance performance, but also create a safety net against failures. If one server goes down, the others step in, keeping everything running smoothly. This setup is crucial for businesses that rely on constant connectivity. With PacketFence clusters, you get the peace of mind that your network is robust, resilient, and ready to handle anything thrown its way. It's all about keeping your operation flowing without a hitch. In PacketFence, a cluster refers to a setup where multiple PacketFence servers work together to provide high availability, HA, load balancing, and fault tolerance. This is especially useful in larger network environments where you can't afford downtime or performance bottlenecks. In PacketFence, a cluster is like a well-oiled machine where multiple servers join forces to ensure high availability and seamless performance. Imagine a network environment so large that even a moment of downtime could spell disaster. That's where clustering shines. In PacketFence, clustering is a game changer. fails, others continue serving. Load balancing distributes network traffic across nodes. Scalability, you can add more nodes as your network grows. Database synchronization uses Galera cluster to keep the database consistent across nodes. Services that can be clustered: Radius, DHCP Web Portal, SNMP Traps, Admin UI. Cluster modes, you can configure active, or active-passive modes depending on the service and performance needs. Configuration, PacketFence provides tools and documentation for setting up clustering. In PacketFence, Radius is like the gatekeeper of your network, ensuring that only the right users and devices gain access. Imagine connecting to Wi-Fi, a VPN, or even a wired port. Radius is working behind the scenes, verifying credentials and enforcing policies. It checks if you're authorized, authenticates your identity, and ensures compliance with security protocols. This means that whether you're a guest or a full-time employee, Radius helps maintain a secure environment by controlling who gets in and what they can do. It's not just about access. It's about protecting the network from unauthorized users and potential threats. With Radius, PacketFence transforms network access control into a seamless, efficient process, keeping your data safe while you connect with ease. In PacketFence, Radius, Remote Authentication Dial-In User Service, is a core component used for network access control, particularly for authenticating users and devices connecting to the network via Wi-Fi, VPN, wired ports, etc. In PacketFence, Radius is like the gatekeeper of your network, ensuring that only the right users and devices gain access. In PacketFence, Radius is the backbone of network access control. Imagine trying to connect to a Wi-Fi network or a VPN. Radius is there, validating your credentials or even your device's MAC address. It's like a digital bouncer, ensuring only the right users get in. PacketFence seamlessly integrates with directory services like LDAP and Active Directory, making authentication smooth and efficient. It can even act as a Radius proxy, communicating with other Radius servers for added flexibility. When you connect to the network, your switches and wireless controllers send Radius requests to PacketFence. Depending on the response, users might be assigned to specific VLANs, have their access blocked, or be redirected to a captive portal for further action. And let's not forget about accounting. PacketFence tracks session times and data usage, providing valuable insights into network activity. Radius in PacketFence isn't just about access. It's about smart, secure, and efficient network management. In PacketFence, Radius, Remote Authentication Dial-In User Service, is a core component used for network access control, particularly for authenticating users and devices connecting to the network via Wi-Fi, VPN, wired ports, etc. Key points about Radius in PacketFence. Authentication and authorization. PacketFence acts as a Radius server to validate users via credentials like username, password, or devices via MAC address before allowing them access. Integration with directory services. PacketFence can authenticate Radius requests against LDAP, Active Directory, Radius proxy to other Radius servers, or local user database. Network devices, switches, WLCs. PacketFence integrates with your switches, wireless controllers, or access points that forward radius requests when a device attempts to connect. Enforcement via VLANs or ACLs. Based on radius response, PacketFence can instruct the network device to assign users to specific VLANs, block access, or redirect to a captive portal. Accounting. PacketFence can collect radius accounting information to track session time, data usage, and more. In PacketFence, navigating the world of network access control is all about allowing you to configure settings, manage devices, and enforce policies. It's like having the keys to a high-tech fortress. On the other hand, admin logon is the entry point for administrators to authenticate their identity. Think of it as the digital fingerprint that ensures only authorized personnel can make critical changes. Together, they create a robust framework for managing network security. With admin access, you can customize user roles and permissions, while admin logon keeps everything secure. Mastering these elements is essential and maintaining a safe environment. In PacketFence, an open source network access control (NAC) system, the terms admin access and admin logon refer to administrators interact with and manage the system. Here's a breakdown of each. In PacketFence, navigating the world of network access control is all about understanding admin access and enforce security policies. It's like having the keys to a high-tech fortress. In PacketFence, understanding admin access and admin logon is crucial for effective network management. Admin access encompasses the permissions that allow administrators to configure everything from network devices to VLANs and firewall rules. It's about having the keys to the kingdom, managing nodes, policies, and user sessions, while also reviewing logs and generating reports. This access is tightly controlled through roles, permissions, and authentication methods like LDAP or Radius, with optional IP restrictions for added security. On the flip side, admin logon is the actual process of logging into the admin interface. Every login attempt, whether successful or not, is meticulously recorded in the logs for audit and security purposes. Depending on your setup, you might even need multi-factor authentication to ensure that only authorized personnel gain entry. So when you log in, you're not just accessing a dashboard. You're stepping into a secure environment where your credentials and roles dictate what you can do. Understanding these concepts is key to maintaining a robust and secure PacketFence system. In PacketFence, an open source network access control (NAC) system, the terms admin access and admin logon refer to the ways administrators interact with and manage the system. Admin access refers to the permissions and methods that allow a user, usually an administrator, to manage and configure PacketFence. Admin access typically includes access to the web-based admin portal, usually at https://. Permissions to configure network devices, VLANs, firewall rules, authentication sources, etc., management of nodes, policies and user sessions, log review, report generation, and alert configuration. Admin access is controlled by the roles and permissions assigned to the admin user, authentication via local database LDAP or Radius, and optional IP-based access restrictions for security. Admin logon usually refers to the event or process of an administrator logging into the admin interface of PacketFence. Admin logon is tracked in PacketFence logs such as var log PacketFence admin.log. Failed or successful logins are recorded for audit and security. Depending on configuration, login may require multi-factor authentication. Admin logon typically means accessing the PacketFence web admin interface, providing valid credentials, and being granted access based on defined admin roles. In summary, admin access is the overall ability and permissions to manage PacketFence via its admin interface, while admin logon is the specific act of logging into the admin interface. In PacketFence, a connector is like the bridge that links our network to the outside world. Imagine it as a versatile plugin that seamlessly integrates with various external systems. Whether it's connecting to directory services like Active Directory or LDAP, or working with identity providers such as SAML, OAuth, or Radius, these connectors enhance our network's capabilities. They enable smooth communication between PacketFence and network equipment like switches and wireless controllers, ensuring that our security policies are enforced consistently. Each connector is designed to streamline operations, making it easier to manage user authentication and access control. This integration not only boosts efficiency, but also fortifies our network security, allowing us to respond swiftly to any potential threats. In essence, connectors are the unsung heroes of PacketFence, empowering us to create a robust and secure network environment. In PacketFence, a connector is a component or plugin that allows PacketFence to integrate with external systems such as directory services like Active Directory, LDAP, identity providers like SAML, OAuth, Radius, or network equipment like switches, wireless controllers, etc. In PacketFence, a connector is like the bridge between your network and the outside world. Imagine it as a skilled translator, taking user credentials and seamlessly forwarding them to identity sources like Active Directory or LDAP for authentication. But it doesn't stop there. It fetches essential attributes, such as group memberships and user roles, which are crucial for making smart enforcement decisions. When it comes to security, connectors are proactive. They trigger enforcement actions based on inputs from external systems, whether it's posture checks or threat feeds. Plus, they're always on alert, handling network events by listening to log sources and integrating with management systems. This means your network stays secure and efficient, all thanks to the powerful role of connectors in PacketFence. In PacketFence, a connector is a component or plugin that allows PacketFence to integrate with external systems such as directory services like Active Directory, LDAP, identity providers like SAML, OAuth, Radius, or network equipment like switches, wireless controllers, etc. More specifically, a connector authenticates users by forwarding credentials to external identity actions, external system inputs, handles network events by listening to log sources or integrating with management systems. In PacketFence, interface with cloud services or external ticketing systems. Configuring and managing connectors connectors. FleetDM is a powerful web-based management tool for OS query, enabling you to monitor and query devices using SQL-like commands. Imagine having the ability to gain deep visibility into your endpoints, ensuring compliance and enhancing security, all in real time. Now, when we talk about PacketFence, we're diving into a robust network access control solution that integrates seamlessly with FleetDM. When PacketFence mentions a FleetDM host, it's referring to the URL or IP address of the FleetDM server. This connection allows PacketFence to pull critical data from endpoints running OS query. It's all about enforcing network policies based on endpoint posture. Think software installed, running processes, and more. This synergy between FleetDM and PacketFence not only boosts visibility, but also empowers smarter decision-making in NAC operations. It's a game changer for security and compliance in today's complex network environments. What is FleetDM? FleetDM is a web-based management tool for OS query, which allows you to query and monitor devices using SQL-like queries. It's commonly used for endpoint visibility, compliance, and security monitoring. In PacketFence, PacketFence is a network access control (NAC) solution, and it integrates with various tools, including FleetDM, to gather more detailed endpoint information. When PacketFence refers to a FleetDM host, it's talking about the URL or IP address of the FleetDM server that PacketFence can connect to in order to pull data from endpoints via OS query, running on client machines. Enforce network policies based on endpoint posture, e.g., software installed, running processes, etc. Enhance visibility and decision-making in NAC operations. In PacketFence, Apache Kafka plays a pivotal role as a high-throughput distributed messaging system. It effectively decouples data producers, like network devices, from consumers, such as logging systems and analytics tools. This separation streamlines the management of real-time data flow, making it easier to scale operations. Consider event streaming. PacketFence generates a massive volume of events, from device connections to authentication attempts. Kafka efficiently handles these streams, ensuring that data is processed and stored without a hitch. Scalability is another key advantage. In large campuses or enterprises with thousands of devices, Kafka supports high-throughput environments seamlessly. It also integrates smoothly with the ELK stack, acting as a reliable buffer that enhances performance and reliability in log processing. Moreover, in microservice architectures, Kafka facilitates asynchronous communication between various components, ensuring that everything runs smoothly. In clustered PacketFence environments, where logs and events need to be shared across nodes, Kafka is indispensable. It's all about optimizing data flow and enhancing system resilience in a dynamic landscape. In PacketFence, Kafka refers to Apache Kafka, a high-throughput distributed messaging system used to handle logs, events, and data streams. PacketFence uses Kafka to decouple data producers, like network devices or internal services, from consumers, such as logging systems, analytics, or alerting modules, making it easier to scale and manage real-time data flow. Kafka in PacketFence. Key uses: event streaming. PacketFence can generate large volumes of events, e.g., device connections, authentication attempts, violations. Kafka helps in streaming these events efficiently for processing or storage. Scalability. By using Kafka, PacketFence supports high-throughput environments like large campuses or enterprises with thousands of devices. Integration with ELK. Kafka often works as a buffer between PacketFence and log processing systems like the ELK stack, Elasticsearch, Logstash, Kibana, improving performance and reliability. Microservice communication. In setups where PacketFence is deployed with microservices or multiple nodes, Kafka enables asynchronous communication between components. Why it matters. Kafka is especially useful in clustered PacketFence environments where logs and events need to be shared or processed by different nodes or systems. In PacketFence, the Status tab is your command center for monitoring the health and performance of your network access control system. Here, you can check the system status, including uptime, resource usage, and the health of critical services. A quick glance at the color-coded indicators tells you everything you need to know. Green means all systems go, while red signals a problem. Moving on to node status, you can see all connected devices, their MAC and IP addresses, and the roles or VLANs assigned to them. This is crucial for managing access control effectively. The network status section provides valuable statistics, like event counters for authentications and violations, along with active violations that need your attention. Finally, the debugging tools offer real-time log access, ping, traceroute capabilities, and SNMP tools for direct checks on enabled devices. This tab is essential for quickly detecting issues, monitoring network load, and ensuring policy enforcement, all in real time. In PacketFence, the Status tab is part of the web-based administrative interface used to monitor the health, performance, and activity of the network access control (NAC) system in real time. PacketFence is often deployed in environments requiring tight control over device access to a network. Here's an overview of the main sections you'll typically find under the Status tab. System status. Uptime. How long the PacketFence server has been running. Resource usage. CPU, memory, disk usage, and network I/O. Service health. Shows the status of critical services. Green means running, red means stopped or error. Cluster info. Shows the health of each node in a multi-node deployment. Node status. Connected devices. Lists current endpoints on the network. MAC and IP addresses. Key identifying information for each device. Roles VLANs. Shows what access control role the device is assigned. Switch port. Info. If SNMP is used, this may show physical switch and port data. Network status and statistics. Event counters. Number of authentications, violations detected, blocked devices, etc. Active violations. Devices currently in violation. Authentication logs. Success failure logs for Radius or captive portal logins. Debugging tools. Log viewers, quick access to real-time logs for troubleshooting. Ping traceroute, test connectivity to other hosts or devices. SNMP tools lets you check SNMP-enabled devices directly. This tab is mainly used by system administrators to quickly detect issues, monitor network load and NAC activity, validate service health, and view real-time device statuses and policy enforcement. The Reports tab in PacketFence is a game changer for network administrators. Imagine having a centralized hub where you can effortlessly generate and view logs and analytics about your network. The dashboard summaries provide a visual snapshot of system activity, showcasing top users and devices at a glance. Authentication reports are invaluable, highlighting both successful and failed login attempts, which helps pinpoint any unusual access behavior. Then there are violation reports, detailing security breaches like malware or rogue devices, complete with timestamps and MAC addresses. Device reports track every endpoint, giving insights into device types and operating systems. User activity reports link network actions to individual users, making auditing straightforward. Connection history is crucial for tracing device movements, while Radius and DHCP logs offer detailed insights into authentication and IP assignments. Plus, the ability to export custom reports means you can tailor the data to your needs or integrate it with external SIEM tools. With these features, monitoring and auditing in network access control environments becomes not just easier, but also more effective. In PacketFence, the Reports tab provides a centralized interface for administrators to generate and view various types of logs and analytics about the network, user activity, security events, and system performance. It's an essential tool for monitoring and auditing in network access control environments. Key features of the Reports tab. Dashboard summaries gives a visual overview of system and network activity. May include charts or graphs showing top users, devices, violations, and connections. Authentication reports list successful and failed authentication attempts, useful for tracking log issues or unusual access behavior. Would you like help with specific report type or setting automated reports in PacketFence? The Audit tab in PacketFence is an essential tool for any network administrator. It provides a comprehensive log of actions and significant system events, allowing us to track user and system activities effectively. With action logs, we can see every change made through the web GUI, whether it's adding devices or modifying policies. Each entry includes user information, so we know exactly who made the changes, which is crucial for accountability, especially in shared admin environments. The timestamp feature records the exact date and time of each action, making it invaluable for forensic investigations. We can also see which specific object was affected, whether it's a device, user, or VLAN, helping us trace the impact of any changes. Plus, the IP address capture is a game changer for detecting unauthorized access or potential misuse. Imagine investigating why a device was mistakenly banned or auditing changes in network access policies. The Audit tab makes these tasks straightforward and efficient. Accessing it is simple. Just log in as an administrator and navigate to Admin Hub Audit. You can even filter logs by date, user, or action type for quick searches. It's all about keeping our network secure and compliant. In PacketFence, the Audit tab is a feature in the web administrative interface that allows administrators to track user and system activities for security, compliance, and troubleshooting purposes. The Audit tab provides a log of administrative actions and significant system events, helping network administrators understand what changes were made, when, and by whom. Here's what you can typically find in the Audit tab. Action logs show actions performed through the web, GUI, including changes to configuration or system settings. User information logs the username of the administrator or user who performed the action, which is useful for tracking accountability in shared admin environments. The timestamp records the exact time and date of each action, which is critical for forensics or timeline-based investigations. Object details shows which object was affected, helping in tracing the impact of the change. The IP address captures the IP address of the client performing the action, which is useful to detect unauthorized access or admin misuse. Example use cases include investigating why a device was mistakenly banned, auditing changes made to network access policies, and detecting unauthorized administrative access or rogue changes. To access the Audit tab in the PacketFence Admin GUI, log in as an administrator, navigate to Admin to Audit, or look under Logs depending on the version. And you can filter logs by date, user, or action type for easier searching. The Nodes tab in PacketFence is essential for managing all devices connected to your network. It provides a comprehensive view incident response, where you can locate and isolate compromised devices quickly, network troubleshooting to identify where a problematic device is and what its status is, and compliance to ensure only registered and compliant devices have full network access. Would you like a screenshot or a step-by-step walk how to use the Nodes tab effectively? The user PacketFence is a powerful for managing network access. Here you can view a comprehensive of all users interacting with your network. Each includes essential details, usernames, roles, and their current status, whether they're active, inactive, or even banned. Searching for specific users is a breeze with the filtering options. Just type in an email and you'll quickly find what you're looking for. Once you click on a user, you gain access to the information, their operation methods, associated devices, connection history, and any security violations. User management is stored. Create, edit, or delete users as needed. You can also ban or unban users, force re-authentication, their roles, and VLANs. If PacketFence is integrated with an identity provider or Active Directory, users are dynamically updated, ensuring you always have the latest information. This tab is crucial for monitoring network activity, investigating suspicious behavior, and enforcing tailored policies. It's all about keeping your network secure and compliant. The Users tab in PacketFence, a network access control (NAC) system, provides detailed management and monitoring features for user identities interacting with the network. Here's an overview of what you can typically find and do within the Users tab. The Users tab is part of the web administration interface. It allows administrators to view, manage, and interact with user-related data. The main features include user listing, which displays a list of all known users in the system. Each row typically includes username or login ID, full name if available, email, role or group, e.g. employee, student, guest, and status, active, inactive, banned, etc. You can search for users by name, username, email, or role, which is useful for quickly locating specific user requirements. Clicking on a user shows detailed information, including authentication method, LDAP, radius, local, etc., devices associated with the user, MAC addresses, IPs, connection history, violations or security events, and access status and policies. User management actions allow you to create, edit, or delete users, depending on authentication backend, ban users, force re-authentication or deletion, and assign users to different roles or VLANs. If PacketFence is integrated with an identity provider, e.g. LDAP, Active Directory, user info might be pulled in dynamically, and some actions may be limited. Authentication sources list which backends were used for authentication, e.g. base, LDAP, SAML, etc. Use cases include monitoring monitoring who is on work and what they're doing, indicating suspicious behavior or policy violations, applying tailored network policies per user or group, and audit and compliance tracking. Wrapping up our PacketFence course, let's recap the essentials and skills we've covered. Explore the purpose of PacketFence in network control, diving into its architecture, including key components like PF, DHCP, DNS, Radius, and MySQL. We learned about instant configuration, comparing standalone deployments, and how to set up networks and interfaces effectively. We tackled VLAN integration using SNMP and Radius QoA, instances of VLAN assignments based on policy. Authentication methods were a big focus, from LDAP to Radius, and we examined role-based access control and enforcement techniques. The captive portal and guest management features were particularly engaging, allowing for customization and self-registration processes. Monitoring and troubleshooting were also key, with tools like TC and health alerts ensuring smooth operations. As you move forward, remember to back up your configurations regularly with a test environment before going live. Keep your systems updated and engage with the community for support. Your next steps? Set up a small deployment, explore advanced scripting, and consider PacketFence with other security tools. Dive in and make the most of your PacketFence journey.